It appears that we are live. Hello, everybody, and welcome to another Hangout. With me today, again, I have Anthony Riley, and we are going to be talking about two different subjects. First of all, we'll start with his quotes regarding angular sizes. And then when that is done, we'll be talking about his claims regarding the core of the planet. But before we start, I have to do a little housekeeping. So I'll host another Hangout next week with Truth Seeker on Wednesday. And don't worry if I sound a little weird on that day, because I'll have another microphone. I ordered another microphone. It will arrive next week. So should my voice be a little bit strange, that's normal. And without further ado, let's start. So welcome, Anthony.
Good evening, Joe. Good evening, chat. How are you all out there? Okay. So let's get this show on the road then. Let's make it short and concise if we can.
Yeah, so again, a little bit backstory. In one of Nathan Oakley's Hangouts, you said in the side chat that, quote, the size of the angle is a measurement, the angular size is the sum.
Correct.
Correct. And that you repeated that in the Skype conversation we recently had, just a little bit differentiated. You said angular size is a measurement, angular size is the sum.
Correct.
All right. So I do not think that you actually know what a sum is, because if you understood the geometry behind how we actually calculate angular sizes, you would understand that claiming it to be a sum doesn't make any sense in terms of arithmetics.
Okay, so where do we want to start with this? Should we start? All right, I'll make the point that I made the other day, and then you can tell me where I go wrong. Okay?
Yeah. What I would like to begin is, do you actually know how to calculate angular sizes of objects?
Well, this is essentially it, isn't it? You have to. Right. It depends on what you mean by the word angular size. If the angular size is simply measuring the angle, that is not per definition. That is not the angular size. That is just the size of the angle.
The angular size is the size of an object. The angular size is basically the angle of the. It's basically, yeah, it's the angular size. So you look at it and it has a certain angle to it.
So
yeah.
I've got a couple of different definitions which I went through in Nathan's chat.
All right, so let's start with that.
Perhaps you could tell me where I've misunderstood, because for me it's really straightforward. It's really simple and straightforward. It says the angular size of an object is determined by its actual size, which we don't know with regards to the sun or the moon, and knowing its distance from the observer. So it's two things. You have to know the angular size and the distance to be able to get the actual size and the distance to get the angular size.
No, that's not correct. Because
okay.
I think you're getting it backwards. You can know the angular size without knowing the distance and the actual size of the object. I can demonstrate that relatively easily if you want.
Okay, well, maybe I'm getting it back to front, but that is what it says.
Yeah. Yeah, if you know the distance to an object and its size, you can calculate its angular size.
Sure.
But it works the other way around as well.
Hang on. Let's just go through the second definition. It says the angular diameter or size. We'll just call it angular size.
I didn't share your screen. Give me a second.
Oh, sorry.
There we go.
Yeah.
All right.
Fine. Oh, does that mean that nobody saw anything I was just showing then?
I think they saw it whenever you were talking, so I guess it's fine.
Okay. So the second definition, which is one that, or it's just a definition, but a second one, and I assert that this is the same. If you say it's different, then maybe we can pick one that you choose. But in any event, the angular size or apparent size is an angular measurement describing how large a sphere or a circle appears from a given point of view. Now, the point is, it says the word from a given point of view. It's not from any given point of view. It's from a. That's fixed. It's finite. It's not infinite.
Yeah, that's correct. The angular size will obviously change if you're at certain positions regarding the object that you're looking at.
The angular, yeah, but that's not the definition.
Yes, it is.
No.
When you go back to it, the distance to any... Look at the first definition again. The distance from the observer doesn't say that the observer is at a fixed point to it. If the observer moves, then the angular size will change.
Yeah, but it says the angular size is determined by its actual size, which in the case of the sun or the moon, we do not know. So,
I disagree with you, but for the sake of argument, let's say we don't know them, all right?
All right, but then we also don't know the distance neither. So really, the only thing that we can do with regards to the sun is measure the angle down here. And
yes, which is per definition the angular size.
No, it's not, because the angular size of an object is determined by its actual size and its distance, which we do not know. We don't know either of them. So all you're doing is measuring the size. That's the angle size, not the angular size.
So you're saying wait. So you're saying that just we don't know the distance and we don't know the actual size doesn't mean we know the angular size.
If you don't know the distance or the actual size, you cannot work out its angular size. Correct.
I have to show you something. I'm gonna share my screen. Can you see my screen?
Yeah, I see.
Wait, I'm just not sure if it's the right monitor. There we go. All right, so I've got a little model here. So we have got an observation point here at the center, and we've got two objects that this observer is looking at. We got this one circle and we got this other one circle, right? And as you can see, the angular size of both objects is 30 degrees. So there's 15 degrees over the x-axis and 15 degrees under it. See that? Hello? I think you muted yourself. Right.
Sorry, I didn't realize I was muted. I was just letting you speak. Yeah, I do see that. I see that. That's fine.
All right. So do you agree that the angular size for that observer at that position for both objects is identical?
No, that's just the angle. That's just that measurement of the angle you've measured.
Yes, but it's also the angular size, and it's identical for both objects.
Yeah, but when we apply the definition, it requires that you know either the actual size or its distance to be able to calculate.
Well, in this case, we do, don't we? We know the distance of the this, for example, at this point, the center of this circle is at 10, x equals 10, and of this circle, it's at x equals 20, right?
Right.
So we know the distance and we know the actual size, and therefore we know the angular size, right?
Yeah.
All right. So therefore, you don't have to know the actual distance and the actual size of the objects to know to be able to measure the angular size.
But the thing is, the angular size requires to know the distance or the actual size to work out the other.
No, in neither definition it does say that it requires it.
Yes, it does. It says it in both of them.
Go for it.
Let's go back to my screen. So if you need to knock yourself off.
Okay, I think the chat should be able to see you now. Oh, wait, they were still seeing your screen. So let's just quickly go back to mine. So this was the drawing.
I can
wait a second. Again, two objects, one circle with a small radius, position x equals 10, second one x equals 20. Same angular size from the observer at x equals 0, y equals 0. Same angular size, different sizes, apparent sizes and distances.
But in this case, you know the distance from the observer.
Yeah, but even if you didn't, let's just say you remove the grading of the x-axis. What difference does it make? You still get the same. You still get the same values, right?
Right. No, not true. Let's you get
the apparent size would still be 30 degrees even if you didn't know the distances.
So let's go back to my screen and let's show what the definition is and let's see whether it matches. So am I now? I think I'm on now, yeah?
I don't know yet. Give me a second. Now you definitely should be.
You've ended the presentation though.
Oh, did I?
Yeah, it said so.
There we go.
There we go.
Is it working? Should be working.
Yeah, I think it's working. So in the definition, it states the angular size is an angular measurement describing how large a sphere or circle appears from a given point of view. Now, what you're showing is essentially this that I've got on here. If I draw some random circles in here, so let me just make these yellow. Hang on, bear with me. And then put the fill color in. No, I can't do fill, can I? It just needs to be the line. So if I put some circles in, I need to make them bigger. Let's get rid of that. Oh, it's shift, isn't it? That's it. So if I put these circles in just so that they touch the lines and they fit in, I'm going to do it a little bit quicker to speed things up. But without knowing the distance, you have any of these possibilities. Agreed?
Yes.
So if you have any of these variabilities, this would be infinite. This could go on continuously off the page, or it could come
that's correct. The object could be infinitely far away and just be larger, or infinitely close and just be smaller.
But does that satisfy the definition? It says,
Can you do me a favor, please? Do you know where you got the first definition from?
yes.
Show it, please.
Hang on. Just let me. Does it answer this? Does it satisfy the definition? The apparent size is an angular measurement describing how large a circle or sphere appears from a given point of view.
Yes, that's correct.
Is any of these a given point of view, a given point of view, or is it any point of view?
No, you don't understand the definition, obviously. The point of view is where the eye is, the observer.
Yeah.
Not where the object is.
But the object could be this, or that, or that.
Yes, correct.
So how can you calculate the actual size when you're looking at any of these?
Only knowing the angular size, you can't.
Well, there you go. So you're not going to know by measuring the angle, the size, or the distance, unless you have one or the other.
Yes, that's correct. But
So
that still, first of all, that still doesn't change the definition, and second of all, that still isn't a sum in any way.
Hang on.
But please do me a favor. Go to the page where you got the first quote or the first definition from.
Okay. I'll open up a new tab. So I guess normally one of the top ones here. I think it's that one. Yeah.
So, perfect astronomer. Yeah, please go up a bit over the picture. There's 2 paragraphs there.
Say that again, Alex.
Scroll up a little. Just a little more. Yeah, see that the second paragraph where it starts a little down, please.
Yeah.
Yes, that one. It starts with angular. Exactly. Please read that one for me.
Angular size is measured in arc minutes and arc seconds, which are used to represent angles on a sphere. An arc second is of 1 degree, and a radian is degrees. So 1 radian equals, which is about seconds. This is useful to astronomers when working out distances, between objects or calculating magnifications required for observations. Angular size is also used as a measure of optical instruments resolving power, basically how small an object can be seen.
All right, so the first sentence, it defines, again, what angular size is. Actually, it gives the units.
Angular size is measured in arc sec. Yeah, okay.
All right. Therefore, angular distance matches the definition what you just said previously.
But angular size is measured in arc minutes and seconds. That's what that's basically doing, is giving you an infinite variable here.
Yeah, so what? It still says that angular size is that the unit for angular size is degrees or arc minutes or arc seconds.
So what you're
Therefore,
saying
it had nothing to do with the distance of the observer to the object. It's just how big the actual angle is.
All right. So what you're saying is that this sentence here, by your interpretation, contradicts this sentence there.
No, it doesn't contradict it. It widens is the wrong word. It's basically the same thing, just backwards. So you actually, again, do you know the calculation that you have to do for a spherical object, for example? How you can determine the angular size?
You didn't answer the question then.
Yeah, I did. I said it doesn't contradict it, but it's the same. It's the same. He's saying the same, just the other way around.
I believe that is this is the equation, the small angle formula.
No. The small angle formula is just that. Yeah, there it is. That sine phi of a. No, it's not phi. Is it theta? Shit,
how
better to Greek letters.
How is this relevant to the definition of angular size?
Please go back. Wait, let me check it. Where was it? Further down, right?
Yeah, go back to that definition.
Small angle formula. What? Small angle. Did you change the page?
Yeah, it was the second page. So you want to go back to
all right, yeah, the small angle formula is approximation. If you don't want your calculations to be as complicated, you can use the small angle formula to make it easier. But for larger angles, it doesn't apply because the error is simply too high.
I'm just trying to find which page it was that I went to. Yeah, this is the one. So what is it you're looking for?
So my original question was, do you actually know how to calculate the angular size of a spherical object as given from a given distance?
But how is that relevant?
It is relevant because I don't think you know what you're talking about.
Well, I can understand the definition.
You should be able to at least show geometrically how this is calculated.
No, I'm just trying to identify what the meaning of the word angular size is.
Yes, and I already corrected you on that.
Well, you say you corrected me, but I disagree with you. It says clearly that it's determined by its actual size and its distance. It's distance, not a distance.
Yes, this sentence describes an equation. It basically says that the angular size is dependent on the distance and the actual size, but it's also the other way around. It says that starting from the angular size, when you know one of the two other measurements, the distance or the actual size, you can calculate the third. That's why I'm asking you if you understand how the equation works.
No, I don't need to know the equation, and it's an irrelevant question. The point, if you're
no, it's not irrelevant, because then you would understand why saying that it's a sum is useless or false. And
all right, I'll give way. You demonstrate the sum, and then you can show me where it's irrelevant.
There is no sum. That's the point.
So then then we're back to the same point.
No, first of all, do you actually know what a sum is? What is a sum?
A sum, a calculation.
Yeah. No, it's not a calculation. That's too broad. What is a sum? Yeah, it's a type of calculation, but what do you actually do? I mean, there's lots of different calculations. There's additions, there's multiplications, there's divisions, potentiations, so on and so forth. But what is a sum?
Why do I need to define the word sum?
Because you claimed that the angular size is a sum. Therefore, you should be able to know what a sum is.
If you measure the angle,
yes,
and you know the distance, there will be a sum somewhere that tells you.
Nope, there's no sum in the formula whatsoever.
So let's just say the angular size on this sun is 30 arc minutes, right?
Yeah.
If it's 30 arc minutes, it'll be set at the distance, which will be 260,000 miles. But if you just say it's 30 arc minutes.
Sum. Did you say sum or sun?
I said, if you measure the angle, so let's go with 30 arc minutes. So if you measure the angle at 30 arc minutes, it means nothing unless you know the distance. So the answer would be 30 arc minutes at 260,000 miles. Otherwise, 30 arc minutes is simply any one of these points along here, and it tells you nothing about what the thing that you're looking at.
Yes, that's correct, but you still don't understand what a sum is. You said, quote unquote, that. Now I have to find the original quote again.
Right. A sum is the answer. The result.
No, there's no sum in the calculation whatsoever. There's no sum in the equation.
So
again, please define what a sum is, because I don't think you understand what a sum is.
A sum is a construct. So 2 + 2 is 4.
What did you say? Just repeat that, just word by word, please.
It's a construct, isn't it?
Go on. So the next thing you said after it's a construct. Go on.
So, for example, 2 + 2 = 4.
Yeah, and please repeat that word by word. That equation. What did you say?
A sum is a construct.
The next one, the next sentence.
For example, 2 + 2 = 4.
Yes, 2 + 2, exactly. A sum is only when you add numbers to each other.
Right, but
any other mathematical equation that you do that does not contain an addition is not a sum.
Right, that's it. Right, all right, I'll give you that, but it distracts from the point that I'm making.
No, it doesn't, because it completely shows that you have no idea about mathematics whatsoever. Otherwise, you would have never made that mistake.
But I can interpret what things say, and what you're interpreting is not consistent with what things say. The only concession that I'm prepared to concede is that this sentence up here appears to contradict this one, because one of them says is measured in arc minutes and arc seconds, which doesn't give reference to the distance, and then the other one says is determined by its actual size.
Yes, correct. It doesn't give. It doesn't talk about the distance, because the distance is irrelevant. As I said, the definition of the angular size is only the apparent angle of the object as seen from a certain point of view. It's not. You don't need to know the distance and the actual size to determine the angular size.
Is this not based on
angular size and angle size are exactly the same?
No, they're not.
Actually, can you find a quote that says that angle size is something different? Because you were quoting angular size all the time.
Angular diameter or angular size is the apparent size.
I know the quote.
From a given point.
I know. Please describe one that says angle size.
You want a definition of angle size?
Yes.
Okay. Each angle of measurement should be the same reference. Let's go with a better.
Because I think that everything that you will find is that defines practically what a degree is, or how we define a full circle. That's all.
It's called measurement. There you go. There's an angle size. How is that the same as an angular size?
Does this one point at a particular object and measure its angle?
No, but
Therefore, it's only showing the
angle size.
Yeah, the angle size.
All right, so let's go back to basics then, because I can see where you don't understand now. It makes sense to me. Let's see. New file. Don't save. Just get 2 lines. Oops.
Oh, by the way, I notice, am I still screen sharing? No, I'm not. All right.
So I'm just looking for me. Where's my little thingy gone? Where's my little paintbrush? What? Oh, there it is. So that is an angular size. Agreed?
Nope.
That's an angle size, no?
Yeah, you just changed the definition. First of all, you said angle size, and then you said angular size.
I stand corrected. I misspoke. That is an angle size.
Yeah. So what happens now when you're looking at the 2 different sides of an object? It then automatically it automatically becomes an angular size of that object as seen from the vantage point.
No, it doesn't. It only becomes an angular size if you know the distance. Otherwise, it's just the size of the angle and nothing more.
No, it's the angular size. You're looking at that. You're looking at that object.
No.
You can determine how much of the sky or of the viewing of the field of view of yours it takes, how big it is as seen from your vantage point. Therefore, it's an angular size.
No, it's an angle size. You've got your terminology incorrect. It's an angle size.
No. As said, you don't need to know the actual size and the actual distance to know the angular size.
Yeah, you do, because it says it's
and actually, I'm pretty sure that you've used angular size the way that I do as well, because flat earthers usually, you know, the argument that on a flat Earth the angular size of the moon needs to change, or of the sun as well needs to change, right?
Alex, it's from a given point of view. You can't get past that. It's not
correct. It's from a given point of view.
A given point of view.
Yes.
Not any given point of view. A.
Yes, as I already said, when you're changing your point of view, the angular size of the object will change. But when you're at that point of view, you can't, first of all, you'll always get the same angular size if neither the object or you are moving. Yeah, that's the point. When you're at a given position and the object is at a given position and you don't know the distance between the 2, the distance between the 2 is irrelevant and the size is irrelevant. As long as the object doesn't change in size.
There you go. You've just said it. As long as the object doesn't change in size, you wouldn't know that if it's if you'd vary in the distance.
No. As long, look, you're looking at an object at a given distance, right?
Yeah, at a given distance.
Yes.
Not any.
No,
at any distance.
Yes, at any given distance.
No. From no, it says a given distance, not any.
Yeah, in one example. We're talking about one specific example here. We don't know the distance.
There's 2 because it says from the observer, not from any observer, from the observer. So that's 2.
Yeah, no. Let's just say first of all, we need a frame of reference.
Yes, we do.
And the frame of reference.
We need. No, stop. You've said it there. We need a frame of reference. So without a frame of reference, you've just got an angle size and nothing more. Ding, ding. I win. Yes.
No, first of all,
it needs a frame of reference. Otherwise, it's an angle size.
Yeah, but let's just first define what the frame of reference is. The frame of reference is, let's just say that you're always in the center of your coordinate system, all right? The observer is always at the center.
Alex, the frame of reference will be your distance.
No.
Yes.
No.
Always.
No.
Or the actual size.
I don't think you understand what a frame of reference is.
I don't think you're not understanding that there has to be a frame of reference.
You didn't also understand what the sum is, so yeah.
We're not going to get to a conclusion, are we?
Yeah, actually we are, because I'm still waiting for an answer. Do you actually know how to calculate it?
I don't need to know how to calculate it.
Yes. Because
Listen.
because when you take a look at the equation, you answer your question.
Let's define the frame of reference. You
And
said
no, let's start with the
listen,
calculation.
You
You
said
have a
we
sphere.
need one, and I agree. Let's define the frame of reference.
Frame of reference.
Let's define what in this example. What is the frame of reference?
All right. So the observer is always at the center of the frame of reference. All right.
Exactly.
The-
So therefore,
okay.
distance is a part of it.
No. As said, you don't have. That's exactly what my example was about. The position of the observer didn't change, but there were two objects at different distances with different sizes that looked identical in angular size from that position.
Alex, we need a frame of reference. You've just said it yourself. Without the frame of reference, there is nothing.
Yeah, but I said it only in the context that when you said we have two different positions, I said, yeah, but it's useful to have one position fixed so we don't have to care about it.
Yeah, but by fixing a position, that gives you the singular point of reference that you need for an angular size. Otherwise, you simply have an angle size.
No, again, when talking about angular size, we're only looking at the apparent size of the object, right?
Yes.
All right, please go back to your definition and you just agree to it. Do you see that in the second definition, angular size and apparent, is it apparent size?
Yeah.
Are synonymous?
The angular diameter, the angular size, apparent diameter, or it doesn't matter what you could phrase it.
Yes, so you just agreed that the two parts are synonymous. Therefore, you agreed that angular size and apparent size are the same.
Angular
Therefore,
size
you
and
agreed that the apparent size is what I described. Therefore, you agreed what I described was also angular size.
No, but you've missed the point. It doesn't say in here angle size. It says angular size. Otherwise, again, it's only the measured size of the angle. Like I said, the size of the angle is a measurement. The angular size is the sum, which is determined by its actual
And
size.
you still don't understand what a sum is.
Is it not based on a squared plus b squared equals c squared?
What again, please?
Is it not based on a squared plus b squared equals c squared?
Nope.
Yeah, it is.
No.
Yeah, it is. It's based on knowing the distance.
Do you actually know what a squared plus b squared equals c squared is?
It's to give you the other side of the triangle that you're trying to measure.
Yes, but in this case it isn't used. It's the Pythagorean theorem
It's
isn't
based
used
on
in this
Pythagorean.
case.
Right,
Yes,
Alex,
but no.
it still requires a frame
You
of
don't
reference.
use the Pythagorean theorem in this equation. You don't.
It's based on a said.
That's why I'm still asking you to produce the actual equation.
It's irrelevant. What the point is it's not the angle size, it's the angular size. Otherwise, you just get a number. It means nothing. Nothing. It means
no.
absolutely nothing.
No. Again,
All right. So we're
So-
clearly not going to agree.
we first of all, we still need to define, or I still want you to find the equation. Because in the equation, there's a hint that tells you that the ratio of distance and, or actually the ratio between apparent size and not apparent size, actual size and distance is irrelevant because it cancels out.
Well, you said we went through this before, and you said that there was no equation.
I said there was an equation, yes. I'm still waiting for you to produce it.
No, you actually said there was no equation.
No, I didn't.
Yeah, you did.
No. I said there is an equation that describes the three
Right. I'm not
the
interested.
three values.
I'm not
It
interested
is-
in the equation. I'm interested in the frame of reference because that is what you need to get the angular size. No frame of reference. It's just an angle.
I'm gonna show
measurement.
you the equation, otherwise we can't proceed.
Well, we're not gonna
Let me share my screen. So, do you see my screen again? So this is the Wikipedia article for angular diameter. There we go. So as you can see, there are two different formulae given. There's this one, right? And there's this one. Let me just pull this in here.
But what is the point that you're trying to achieve here?
My point is the following. Do you see that first of all, we need this equation here because we're dealing with spherical objects instead of disks. So this is accounting for 3 dimensions. This is only accounting for 2.
Stop. Can you highlight the paragraph that reads, for a spherical object whose actual diameter equals d and where d
Yes.
is the distance to the center of the sphere, the angular
Yes.
diameter can be found by the form. You don't know the diameter. If you don't know the distance, you cannot complete the sum. It requires the distance.
Yeah, as I've repeatedly said, to find the third one, you always need two, because there's the angle, there's the angular size, there's the distance, and there's the actual size of the object. Again, look at this equation. Do you see that ratio over here?
Right, but read what it
No,
says.
no, stop. Do you see that ratio, this one here? D actual divided by 2D. Do you see that?
Yes, I see that.
Okay, what does that mean?
Well,
What happens if you double the actual size and you double the distance, as I did here? What happens?
Hang on.
What happens to the angle?
The application of maths is irrelevant. Let's look at what it says for.
Did you just say that the application of maths is irrelevant?
In this, the application of maths in this example you're showing is irrelevant. Look at the wording above it. For a spherical object whose actual diameter equals this, and where d is the distance to the center of the sphere, the angular diameter can be found by the formula. So if you do not know the d in the distance to the center of the sphere, can the formula be found? Can the angular diameter be found?
Yes, I repeatedly said no.
But so you need to know the distance.
No. Just because you aren't able to calculate the other value or the other values that you're looking for doesn't mean that you can't find the first value, which is the angle.
No, but you would need to know the distance or the actual.
No.
Yes.
No. The delta, which is the angle that I described. In this case, it's 30 degrees. Where is it? Here is it. In this case, 30 degrees. That is measurable. Do you agree that that is measurable?
Sorry, you broke up then, Alex.
All right. Again. So in this calculation, this delta here, right?
Yeah, go on.
That is this angle from here to here, this angle right there. In this case, this is 15 plus 15 equals 30 degrees. The reason it's written as two parts is because I started with the x-axis and then did this part first, and this is just because of the program. So the actual angular size here is 30 degrees, right?
Okay.
And do you agree that you can measure that?
Yeah.
All right. Therefore, you can measure the angular size.
No,
because
you can't.
yes, you just agreed that you can measure this delta.
Yes,
and that is the
definition
the angular diameter.
Right, but by definition, it requires the d and the distance to the center of the sphere, which you do not know.
No, the calculation only describes that when you know two, you can calculate the third. It doesn't It does not mandate that you need to know that you need to know all three for the calculation to be true. That is not the case.
You need to know two.
No, you don't.
Alex, read what it says. It says for a
I know that you can only only have all three values when you at least know two, because you can calculate the third. But it does not say that this equation doesn't apply when you don't know two of the measurements.
Well, it doesn't say that, but if you don't know,
yeah, it doesn't say that. Correct. You can calculate the.
Hang on. If you don't know the values, the sum will not work. Simple.
First of all, again, there is no sum. You still don't understand what the sum is.
For fuck's sake. Are you seriously kidding me? You're trolling me now.
No, you.
It says it in black and white, Alex. Read what it says again. This must be
again for a spherical object whose actual diameter equals the ACT, and where big D is the distance to the center of the sphere, the angular diameter can be found by the formula, and then there comes the formula. Can be found. That does not mean that you can't measure one without.
All right,
that you can't measure one.
Let me try putting it a different way.
You are able to measure one, right?
Let me put it a different way, because obviously this bit's not going in. We'll try it a second way. Do you know the actual diameter of the sun? The actual diameter?
Yes, we do.
Apparently, right? But I assert that you don't. But
all right, let's just say for the sake of argument, we don't know the distance to the sun, and we don't know the actual size of the sun. All right?
Does the sum work?
What a weird question, because again, there is no sum. Yes. Oh shit! I just broke.
All right. Does the equation work?
Yes, the equation works. We just can't solve it because there's one. There's one or two.
But you've just said it. The equation works, but you can't solve it.
Yes, the equation works. That means the equation is valid. Therefore, we can measure. Do you agree that we have to, no matter from which side of the equation we are starting, right? First of all, before finding out the third value, we have to measure two values.
Yes.
All right.
That's the whole point.
No, that means that if we know one, we can't, first of all, we can't determine the third, obviously, because we don't have the second.
There you go. You've just said it.
Yes, no, that's not my point. What I'm saying
that's
is...
my point, though, because you
Yeah.
can measure the angle, but without knowing the actual size or the distance, the formula is incomplete and will not work.
The formula works anyway, we just can't solve it.
All right, the formula works anyway, but you just can't solve it, meaning you need to know the actual size or the distance plus the angle.
Yes, to solve
There you
for
go.
the...
You lost your point.
No. For fuck's sake. Let me just make my point once, okay? Because you keep interrupting me. Like, after I say one word, you just keep interrupting me. Let me just explain it again. Do you agree that in a given scenario, when you're looking from the outside, you see it from the side like we do here. Here in this example, we can measure all three values, right?
No, I don't agree that.
In this example here, right here. I mean, this geometric example, not the sun and the moon thing.
No, because in
this one, I literally have it here on virtual paper.
Yeah, that's because you've got grid lines that give you the distance. You've got grid lines that give you the actual size.
I could hold my fucking ruler on the monitor and measure it.
Yes, but what I'm saying is, in this instance, you've got integers that give you the distance, and you've got integers that give you the actual size. You do not have that in the sky.
Yes, that is correct. But we still have a device that we can use to measure the angle.
But you don't know the actual size, and that's required.
But we do know the actual angle.
But that means nothing.
Yes, it does.
No, it means nothing because you need to know the actual size or the distance. Otherwise, you can't rearrange it for it to work.
As said, the equation works anyway. We just can't solve it. That does not change the fact
Stop saying that. I know it's technically and semantically correct, but
no, it's not. Yeah, what do you mean by technically and semantically correct?
Technically and semantically correct to say that the
everything
equation
I'm saying that is no matter if we know the second or the third value, we can still measure the actual angle. That is independent of whether we have the second or the third angle. But as you just said it.
No, that's all you can do. Nothing more. You can measure the angle, but nothing more.
Therefore, you agreed that we're working with this formula, right?
Alex.
That's a yes or a no. We're working with this formula. Can you measure that angle?
You can
without knowing the other two.
You can measure the angle, yes, but you cannot get
all right,
the
therefore,
size.
So let's just take this apart. We can measure that delta, which is in this case the angular diameter, without knowing the rest. Therefore, we can measure the angular diameter.
You can't, right? The problem, what you're doing there is you're conflating the term linear size and angular size.
No.
No, the linear size, the actual size.
No. Yes. Correct. First of all, I'm not mixing that up. The DACT is the actual size. In this case, the actual diameter. So
we don't know that with the moon or the sun.
That is irrelevant. We can still measure delta.
Yeah, you can measure delta, but it stops there.
Stop. Yeah, we can measure delta. Therefore, we can measure the angular diameter.
No.
Yeah, you just said that.
You can measure the angle and nothing more. You can measure delta, nothing more.
Yeah, and delta is the angular diameter, as you said in this quote that you showed me.
Right, read it again, Alex. For a spherical object whose actual diameter equals d act, and where d is the distance to the center of the sphere, the angular diameter can be found with the formula. Boosh.
Yes.
It doesn't.
Yes, that's correct. But it's the other way around. When we have the angular diameter, we could calculate the other two if we have one of them.
Alex,
but we are still able to measure the angular diameter.
No, you're measuring the angle.
No. What this sentence is saying is that if we have the other two, the distance and the distance from the object and the diameter, we should go through this one.
Precisely, that's my point. If you
then you can calculate delta, but it also implies that knowing.
No, it doesn't imply.
Knowing delta.
No, it implies it if you change the meaning of words.
Nope, because you don't understand the equation.
No, because
no, stop.
You're misrepresenting the meaning of words.
No, stop. Look at this. You have the delta, right?
Yes.
Do you understand that only with the delta you can calculate this entire thing?
But that's to infinity, Alex.
That's important. You can calculate that ratio between those two values
only
with knowing the delta.
No, it's to infinity.
What do you mean by to infinity?
You're measuring the angle to infinity. You're not measuring it to a point.
So what? You can still
determine
not
angular size. It's the size of the angle you've measured.
Look, do you understand that when you know the delta, you automatically know the ratio between these two values?
Yeah, but you don't know you might know the ratio, but you don't know
Yes.
the values.
Yes, you know the ratio.
You
And
don't know the
that's what
values.
this demonstrates. That's not important if you know the values.
No, but you don't know the values. That's the point.
Yeah, as I said, it's not important.
No,
you know
it is, because otherwise you're not getting the angular size. You're just getting the size of the angle.
you know the ratio, right? You understand that you can write that d equal. Let's just say you call this entire thing inside these how these things call in English, whatever. This entire thing here, right? Let's just equal that to c.
You have to assume the distance, Alex.
No, yes. When you want the actual distance you want, when you want that one, then yeah, you have to assume it. But you can calculate the ratio of the two, which is this part of the formula directly.
Yeah, calculate that.
Yes, starting from where?
From the point of view of the observer.
And what is the input that they put into the formula?
You wouldn't know because you don't know it.
Nope. Let's just say what I need my mathematics program.
No. What you're trying to do, you're trying to conflate the term angular size with angle size, and that's completely not true.
Let me show this to you.
We're getting to the point, Alex, where I'm going to say let's move on.
Let me just show this to you. All right. So I'm going to use Word because I know how to operate the formula editor. So in this case, we had I'm too lazy for Greek letters. So 2 arcs in arc. Fuck's sake, I can't type today. Sine.
Alex, what point are you trying to achieve here, though?
Let me show it. There we go.
The only point you're making here is that the formula works. You are not giving a value to the angular size.
2D, right? And that was 2 arcs. I hate it.
You're not going to win. You're not going to win the point with this. All you're showing is that the sum works.
See, let's just define this equation, right? So the angle that you can measure equals twice arcsin of the actual size divided by twice the distance. And what I did here was I just called this term here c. Okay? So c equals this divided by this. Otherwise, the equation doesn't change. Okay?
Fine.
Okay. So what you're saying is that you can directly calculate the ratio of those two values.
Yeah, the ratio I have no problem with.
Yes,
the value
starting from only the angular size.
Right. So what you're saying is, what you're actually showing is linear size is the ratio of the angular size over an infinite distance. Nothing more.
No. First of all, you forget that there's a sinus in the arcsine function. It's not the ratio directly. It's the sign of the ratio.
You used the word ratio a second ago. Why is it now not the case?
I said that you can calculate the ratio, but you have to apply this operator first.
No.
So let's say you want to take this apart.
Hang on. Calculating the ratio does not give you the distance to the sun or the moon.
Yes, but it gives you, as said, it gives you the ratio between the two.
Alex.
And not the sum, by the way.
Alex, calculating the variable just gives you an infinite. Calculating the ratio gives you an infinite variable. It does not give you an actual distance.
No. No. Stop. First of all, I'm hearing myself. Can you maybe put down your speakers a little?
I'll put it on mute a second. It's been acting daft since I've done an update, but I'll just try muting it.
Yeah, just put it a little down. It's just rarely that happens, but it does happen. So, all right. Again, you agree that you can calculate the ratio between those two values, right?
Yes.
Starting from.
Do you agree?
No, stop! I wasn't finished. Starting from only the delta.
Yes, but that's not the contentious issue.
All right. What would a value like this look like? Let's just say you solve this equation for this one. You start with the delta, you plug it through your formula.
Yeah, but you'd
Well-
never be able to solve it without known values. That's my point.
Actually, let's just throw this middle part out here. Oops.
Right, you're getting woolly now, and it's getting
No.
vague.
The heck is this? Let's just throw this entire stuff.
Alex, I'm going to
out.
call 2 minutes on this because I want to get to the meaty point of the conversation.
Just give a second. It's weird here. So let's just say I just threw the middle part out. Delta equals 2 times arcsine C. How would C look like?
What does C stand for? What is C in this equation?
That is irrelevant.
How would C? I have no idea. What point are you making, though?
What would it look like?
I don't
Would
know
it
what
be
C is.
Yes, but would it be a number or what would it be?
Delta being the angle, the measured angle equals 2 arcsine. Is that what you're saying? 2 arcsine C.
Yes. So when you solve for C, what
Why is
would
this
C
relevant?
actually be?
What is your point by this?
Because as said, what would you get? Because when you're solving, when you're taking that equation apart and you
You
have
would get a number. You would just get a number.
right a number.
Yeah, nothing
Yes.
else. Just a number.
Yes, a number, correct. But again, you would get a value that is directly descriptive of the system that you have, namely this diameter divided by 2 times the distance. Do you agree that that is a fixed value for the angle, right?
In
That's
this example,
what the
in
equation
this
describes.
example only, yes.
All right. No, not in every example.
No, it's not. How can it be
Yes.
in every example if you don't? Right. So it comes
Is-
back to
is there-
how do
is
you know
there-
the distance to the sun?
Is there any number
No.
in this except for the 2? But that's a mathematical consequence of the system, of the geometry. Is there any actual distance given in this equation? Right now,
No, it's a ratio, isn't it?
correct. Therefore, it's independent of distance.
No.
This is
No,
this
you're
applies.
conflating the
Stop.
terms.
This applies for every case. If I
Alex,
take a
you're being
completely different
dishonest.
system where I just have, let's say,
Alex.
1 degree of angular size, and therefore this ball, if it had the same size, would have been much further away
Alex,
for it to have the same angular size. This equation here would still apply, only that you would put in different values, right?
no. All
Yes.
you're doing when you're doing this, when you're comparing the ratio and saying that the ratio is correct and it works, all you're doing is demonstrating the infinite variable that is where the distance is to the moon anywhere along
Do
them
you
two
actually
lines.
know? Define infinite variable.
Anywhere along them two, anywhere in between and touching the 2 lines. But you are not doing it from a specific point, and that's what it requires. And by suggesting that the ratio is somehow the same, you are conflating the terms, and that's wrong. You have to have a
No.
fixed point.
No,
and you
what
do
I'm
not
saying,
know it.
I'm saying is I can describe a part of the
Yeah,
system.
describe, but you can't prove. It's based on assumptions, Alex. You can't prove it.
No, that's wrong. I can prove that the ratio between the 2 numbers is given.
Yeah,
Only
and I
by
don't dispute that.
do you agree? Only knowing the angle, I can prove the ratio of the 2 other values.
Yes, I agree. Only
All
the
right,
ratio.
then you have to correct your last statement.
No, you can't tell the distance from a ratio.
No,
When
you
you
said
apply the
you
ratio,
said,
you
you
can't
said
tell the
earlier that I couldn't prove the ratio, but I can prove the ratio.
No, I didn't. I agreed with you. The ratio was correct, and it'll always work out. But what I don't agree with you is that you can determine the distance by just applying the ratio because it gives you the infinite variable. You don't get a fixed point.
Yes. So what? It's
so
not
I'm
relevant.
right, you're wrong.
No.
It needs to have a fixed. The distance needs to be fixed, or the actual size needs to be fixed. Then you can work out the others. Otherwise, the ratio is demonstrating the infinite variable.
As said, you don't have to work them out. The equation applies
Agreed.
if you know 2 of the values or not.
Yeah, the ratio applies, but it doesn't give you.
No, the entire equation applies.
Yes, I agree. It applies.
All right, therefore you can measure the angular diameter.
No, you can only
Yes,
measure
it's a direct consequence of you
No.
confirming that the equation applies and
No.
that there's an angular diameter delta in the
You're
equation.
conflating the term ratio to get to you're using interchangeably the word ratio to give you specifics, and it doesn't work. A ratio is not specifics. It's the
Yes, it
infinite
is,
variable
it
it
is.
gives you, and nothing more.
Yes, it actually is specifics. A ratio is specifics. For example, let's just say you're driving 50 miles with your car, right?
Alex,
As
it
an
isn't
analogy.
specific.
No. Please let me get this example across.
No, because you're getting on my nerves now, and I want to get onto the other topic.
Well, yeah, just give me 1 minute, okay?
Okay.
Let's just say with your Range Rover, you're driving 50 miles. Okay?
Yeah, go on.
And on the distance, you need 1 gallon of fuel. Okay?
Yeah, go on.
All right. from that, you can calculate the amount of miles that you can drive per gallon. Agreed?
Yes.
Now, that value in miles per gallon, is that specific?
No.
Yes, it is.
No, it isn't.
Yes, it's a
It's an
ratio, and it's
What would
yes,
be
sure.
specific would be saying, based on X amount of miles and X amount of fuel in the tank, I should get a Y value, which will be the distance that I can travel. That is specific. But if you don't know how much fuel is in there, or you don't know how fast you're going to drive the engine, then you're not gonna get-
we already said that you need one gallon.
Yeah, but if you don't know how fast you're going to drive the engine, which will be the other variable in that equation, which you don't know.
No. It's the other way around. In my specific example, I specifically said that you need 1 gallon and you can travel with it 50 miles.
So
Okay.
in that case, you know both the variables, the fixed.
Correct. But you also know the ratio between the two.
Yes, but in this instance,
All right.
with the
So
sun on you,
using
you
the
don't know.
ratio between the two
Wait,
is valid
wait.
because you can
You've just
extrapolate
made-
one value that you get out of it to another one.
Extrapolate, but not prove.
Yes.
No.
If I know my car,
Alex.
if I know, for example, with 1 tank of gas, I can drive 650 kilometers. That means that I can expect that for 10 times or
Yeah.
10.
Now let's apply that
tanks, I
phrase.
can drive 6,500 kilometers.
Let's apply that phrase to the sun. If you know the distance to the sun or its actual size, then you can calculate the rest.
Yes,
Alex,
but we know the ratio anyways.
I know that you understand this, and I know that you're trolling me at this point, because if you honestly believe what you're talking about, you're either being dishonest or you are not.
No,
intelligent.
because I'm actually describing a mathematical calculation and saying only because you don't have all the values, or only because we can't solve it doesn't mean that it's completely invalid.
The ratio does not give you anything physical, real. You are not getting.
Yes, it does.
No, it doesn't.
And in the
gives you an
car example, it
infinite
did as well.
variable. It gives you an infinite variable and nothing better, nothing more.
No. You know how much fuel your car needs per mile, right? Approximately. I mean, you can calculate in any value you want. You can have it in, as we in Germany do, in liters per 100 kilometers. That's the exact same thing, just turned around and converted to metric. But you can use that value to extrapolate, to estimate how much fuel you will need over shorter distances and over longer distances. Therefore, it's valuable to know that value. And that's what we are doing here, only knowing the delta.
Alex, you had it right the first time when you said we need a frame of reference. You have to predefine the terms. If you don't predefine the terms, you have no frame of reference and you cannot complete the sum.
Again, it's not a sum.
Whatever.
Yeah, whatever's showing me that you don't have any clue what you're talking about.
No, you don't have any clue what you're talking about, because you're claiming that a ratio gives you a definite answer, a definitive answer.
No, I'm saying a ratio itself is a definitive answer.
No, it isn't. It's a continuous variable. Alex, stop being...
No, a ratio isn't a variable. If the ratio in this case would be we have this delta, right? That is given. We can measure that. Therefore, we know the value. It will not change. The value of the ratio is given.
Yes.
If we know the delta.
But that gives you a continuous variable.
It's not a variable anymore.
No, the angle will always be the same. The continuous variable is...
Therefore, neither the angle is then a variable. That's something we measure. That's something given.
Alex,
and the ratio between the two is also a given thing at that point.
No, it's a continuous variable. It's not.
As said, what is a variable? Do you know what a variable is?
Yes.
What is it? Define it.
It's anywhere between. In this case, it's where the sun fits anywhere between the two lines.
Just in general, define it.
A variable, something that doesn't remain constant.
All right. Is the ratio constant when we know the delta?
The ratio is constant, yes.
Correct. Therefore, it's not variable.
No, the ratio gives you an infinite variable, because you can put any number in and you'll get a different number out. But if you put... Yeah.
I mean, yes, but that has nothing to do with the statement that I said further.
Well, it does. In this instance, Alex, we're talking about the sun, for example. You need to know the distance to get the angular size. Otherwise, all you've got is a number that relates to the size of the angle. Nothing more. The ratio for the formula works. However, you don't get fixed. You don't get the, like you said, the sum cannot be completed without knowing the actual details.
Again, it's not a sum.
Whatever.
Please stop using the word sum. It drives me crazy.
Right, let's move on, because obviously we're not going to get anywhere with it. The bottom line is I was correct.
No, you weren't.
The size of the angle is just a measure.
If I had a mathematician or anybody who would actually know how to define these terms accurately,
Well,
Or
you've
more
got the
accurately.
definition. You've got the definition there. It says for a spherical object whose actual diameter equals d act, and where the d is the distance to the center of the sphere, the angular diameter can be found by the following formula.
Correct. The angular diameter can be found if you know the other two. But
Yes,
you can
if
turn.
you
But
know
you
the
can
other
turn this equation around. Don't you get that? You
So
can
what-
start.
I understand that.
You can start with the angular distance and not be able to calculate the other two because you don't know the one of the other two.
That's my point precisely.
Yes,
What
but
you've just said
the
there.
definition of the equation, the equation itself is still valid, right?
The ratio of the equation is still valid, but
The equation is still valid. Thank you. That means you can actually measure the angular size without being able to solve it for the other two. Because you don't know the other two.
okay. But that then gives you
Yeah,
an
thanks.
answer that
You
you
just conceded that you were wrong.
No. What? No, you didn't let me finish. If I accept that, then you never get an actual a finite distance to the sun. You
That's
get
not relevant.
continuous
Again,
variable.
it isn't
It is.
relevant.
No, it's not.
No.
It's completely relevant because all you're doing with the ratio, Alex, is varying where the sun sits on the line. The sun can sit at 10, 20, 30, 40, 50, and you don't know where it's sat at because
Yes, correct.
because the ratio is giving you that as an answer. You can put anything in it and you'll get something out of it and you say the sun could be there. But it also could be somewhere else if you put it in a different value.
That
Because you
is correct. And I repeatedly said that nowhere in this equation does it say that in every case we need to be able to calculate the other two values.
But
The
it
equation
says-
itself is still geometrically valid.
But it says,
this-
Alex, it says
No,
the
no, no,
angular-
stop.
No,
Stop.
Alex, it says specifically that angular diameter can be found by the formula. So
Yes,
if you don't know them,
can, not must.
no, can meaning the operative word. The opposite would be if you don't know the other values, it can't be found by the formula.
Yeah,
Alex,
if
it's
it's saying that it can be found by the value means that you
Means
would.
if you don't know the other two values, it can't. That's what it means.
Yes, but the fact that they are using can,
No, you've just admitted it.
the fact that they're using can means that they are saying that it's not in every case possible because the other two values are not known. For example, let's just say there's a geometrical formula where you have one value, you plug it in, and it directly gives you out another value. For example, when you're converting degrees into radians, right? That's just one factor between the two. Conversion factor, right? Yes or no?
Alex,
Yes or no?
I give in. You're not. If you can't see this by now, you're not as good at maths as what you claim you are.
You have no idea what the sum is. I think that speaks for itself.
Yeah, but you don't understand what the word "can" means in this context.
Yes, I actually do. It says it can be found for a spherical object whose actual diameter equals dAct and where d is the distance to the center of the sphere. Meaning, you know, dAct and big D. Big D. The angular diameter can be found by the formula delta equals yada, yada, yada. That means in this example, in this sentence, they already have the distance from the observer to the object, and they already have the size, the actual size of the object.
Exactly. That's the point. You don't have that with the sun or the moon.
Correct. We are starting the equation from the other side. That doesn't mean only because we can't solve it because we don't have the other values doesn't mean the equation is geometrically not valid.
And that's not my argument.
Yes, that is exactly your argument because you're saying that delta
No, it's
isn't.
not. Stop misrepresenting my point. I've put it in the
Yes,
side chat. So
you
it can't be
interrupted me
mistaken.
again. That what
Because
you've said in the
talking-
beginning, angle size isn't angular size. You said that.
Correct.
All right, but you said when we that you 1 minute ago you said that it's not your point that this equation is not valid when you can't calculate the actual distance and
The equation is always valid.
the equation is always valid. Therefore, the angular diameter is always valid, right?
Yeah, but in this equation, Alex, the angular diameter is only capable of being calculated if you know the distance, because it says it in black and white. Where d is the distance to the center of the sphere, which you do not know. So if
Yes.
you know the distance, the angular diameter can be found by the formula. Therefore, the opposite is true as well. Where the distance to the center of the sphere is not known, the angular diameter cannot be found.
Correct, but we're starting from the other side. We know the angular diameter.
Alex, I can't be asked. There's no point carrying on. If you can't understand what that grammatical construction of the sentence means, we should put it down to a translation thing, because you are either trolling me or you're being dishonest, because it clearly says where the distance to the center of the sphere is known, the angular diameter can be found.
All
Clearly
right.
says it.
So, okay, let's continue to the next point. But I still have one question. Do you agree that we can measure delta in this case?
Yes, we can measure the angle.
All right, thank you. Let's continue.
Which is what I said. The size of the angle is a measurement. You've just said that exact phrase. The size of the angle is a measurement. You said, do you agree we can measure delta? Yes.
Yes, and what is delta in this equation?
Pardon?
How is it given right in this equation?
How is what given delta?
The delta, how is it defined in the sentence that you read all the time? That you wanted to have me described?
Well, where's delta in the... I can't read it now because it's too small. Just unhighlight it.
Nope, that was too much. Delta is the angular diameter.
Yeah, but it's calculated. It's not ratioed.
But you said before that you can measure it directly. Therefore, the angular diameter can be measured directly.
Not the angular diameter. The angular, it says clearly, the angular diameter can be found by the formula. That's a sum.
For fuck's sake, just stop saying sum.
I've not said then.
I asked you, can you measure the delta?
You can measure the angle, yes. But you can't measure the angular diameter without doing the formula.
It's the same thing. It's literally synonymous.
No, it isn't.
Yes, it is.
No, it isn't, Alex. Measuring the angle is not giving you the angular diameter. It's simple. You have to go through the sum.
Can you find any formula that defines the angle of an object over a given distance other than this formula? Well, maybe it's rearranged to start with an. Maybe it's rearranged.
Alex, the angular diameter is not the actual diameter. Do we agree?
I agree. Yes.
There you go. It doesn't need
different
to go
units. The actual diameter is given as a distance in meters, for example, but the angular diameter is the value in degrees.
Right. Listen. We're clearly not going to get there, and neither of us going to give way. Okay. So let's move on, because we're spending a long time on this, and we're not getting anywhere on it. We're still at the circular reasoning point. Let's move to the other point.
The other point, that was a few days ago, you were talking about the properties that you think the inside of the Earth must have, right?
No. Let's read what I actually put. I'll read it. The Curie temperature of iron is long since passed or met with regards to the temperature of the claimed temperature of the Earth's core, according to your accepted model. This cannot result in a magnetic core without an external magnetic source. That's what I said, because I said the Curie temperature is passed, it loses its magnetism. Because it loses its magnetism, it needs an external source for it to be magnetized. It can't be magnetic by itself. So what is that source?
First of all, you know that non-ferromagnetic materials can produce a magnetic field once, as you said, an external source is applied. In the case, for example, copper wires, it's electricity, right?
Yeah.
All right. So when...
Well, hang on. Given that it's my assertion, let's just start with some common ground that we both agree on. Do we agree that the inner core on your model is solid?
The inner core is probably solid, yes.
Well, it is solid.
As I said, I'm not an expert on this. If we would get Purple Dan in here, that would be perfect. By the way, is he online? No, he's not online. What a shame.
Sorry, I didn't realize I wasn't screen sharing then.
Oh, sorry. Let me just share a screen. There we go.
You can see my screen now, yeah?
I can see it. I'm just waiting for the chat. They should be soon able to see it. Yeah, they can see it.
Right. So on your model, the inner core, according to all the documents I've found, clearly states on all of them solid.
Correct.
So when we look at the melting point in Celsius,
yeah, and the boiling, it's over the boiling point. I know.
Yeah, but it's over it by what, 7,200 degrees Celsius. So call it. Let's round it down to 5,000 for easy maths. It's more than double, isn't it? It's like huge amounts more.
Yeah, it's approximately 3 times. Yeah.
How can something exist as a solid when the boiling point has gone beyond itself significantly?
Do you understand that the boiling point of something is dependent on the outside pressure of it?
It doesn't say that. It says the boiling point is 2800 degrees.
Yeah, and when you look for boiling point, there's always a standard boiling point, meaning at 1 atmosphere of pressure. For example, water, when you go into high mountain ranges, the boiling point of water actually decreases to the point where you literally can't boil your food anymore because the temperature of the boiling water isn't high enough to change its structure. You can't hard boil potatoes on Mount Everest, not hard boil, soft boil, or boiling potatoes. You can't do that on Mount Everest because the boiling point of water at that altitude, because of the outside pressure, is too low to do anything with the potatoes.
So what you're saying is
also the reason. That's also the reason why there's an Armstrong limit. That is the point where the pressure gets so low that the boiling point of water is lower than the body temperature of people.
Sure, and I would agree with that because in a vacuum, water will boil, right?
It immediately boils. It's immediately starting to boil, yes. And by the way, this is something that I'm using in the lab every day.
Okay, and I agree with you. At this point, I agree with you.
All right, so do you agree that we can extrapolate that into the other direction? When you set water under pressure, like in a, do you know these steam high-speed cooking devices?
Yeah.
That you have to lock? Yeah, they work by increasing the pressure inside the vessel so you can have higher cooking temperatures.
So what you're arguing essentially is that we're going into the realms of supercritical fluids, right?
Well, no. Do you actually know what a supercritical fluid is?
But do you want the actual definition or in general?
No. Without looking up for a definition, can you describe what the supercritical fluid is?
It's the point where it goes beyond its critical point.
Which point? And what is define the critical point and define what point you're talking about?
Equilibrium curve. I'm looking it up on Wikipedia.
Not on Wikipedia. You should be able to describe it if you bring up the point.
No, I don't know. This is just completely bullshit.
Let's just start with about phase.
No.
I give you a little hint. Start with the phase diagram of the substance point.
If you're expecting me to know the definition of how things work, so otherwise you're not going to accept the point, then there's no point in even having the conversation.
No, in this case you brought it up. You should be able to describe it at least.
No. That's the whole point of Wikipedia. It does it for me.
It does. Yes, it does inform you. But if you bring up the point, you should be informed about it without having to look it up.
No, that's what you're going to do and counter. That's called a debate. I'm going to say something,
no,
you're going to counter it.
Because I actually know what I'm talking about because I learned this stuff.
That's fine, and I have no problem admitting that I don't because I didn't learn the stuff.
All right, then do me a favor and look up phase diagram for iron.
So you're gonna have to say that again. Do what?
Phase diagram of iron.
The phase diagram of iron. All right, hang on.
Phase diagram of iron.
Phase diagram of iron. Click images, yeah?
Yes. That's iron carbon phase diagram. Temperature. Oh, that's shitty.
Well, okay.
Yeah, see the one. Oh, for fuck's sake! I would have to look it up myself. Let's just go back. Do me a favor because I don't know how the actual phase diagram of iron looks like, without having to look it up. Do me a favor and search for phase diagram of water. Just as an analogy. There we go.
It's because I spelled phase wrong. F-A-S-E, I spelled it.
Yeah, it's P-H-A-S-E.
Phase diagram.
There we go. See the one on the
I can do it
second. Yeah, no. Let's continue with water because it's talking about points that we actually can make easily in labs. None of that one. Go 3 further to the left. It's the best one in terms of how it's looking. Yeah, that one.
Can I just ask why we're talking about water rather than iron?
Yeah, because I can describe it more easily with water.
Right, that's not going to mean anything to me though. Can we not do it with iron because that's what the core of
Yeah, all right, but I don't know if the phase diagrams of pure iron I mentioned.
So why are you bringing it up then if you don't know about it?
Because I know how phase diagrams in general behave.
Yeah, but so that case you should be able to apply the general principles to iron. Let's do that.
Yes.
Because you can't bring something up if you don't know about it. That's what you just said to me.
Because I'm not familiar with crystal structures of iron.
So why did you bring it up?
I couldn't identify what, for example, liquid.
Is it one rule for me and a different rule for you, Alex?
No, it isn't.
Right. So why did you bring it up?
There we go. That one is nice. So do you see? So you say, yeah, that one is great. Pure iron phase diagram. At the bottom, you have the axis with the pressure, right?
Sure.
All right. So go to an x value of 1 bar.
Okay.
And now go up until you reach the line between vapor and liquid.
Yeah.
It's like 2,800 or something.
Okay.
All right. Wasn't your evaporation temperature of iron in the source that you showed before at 2,800 degrees?
Boiling point 2,800.
Yes, that's the evaporation. That's the boiling point. Okay. Now look
Well,
at the slope.
Hang on.
Yeah.
What point did I get that right then? That was the point where the liquid changes to the vapor. 2,800. It was right. Correct.
Yes, but only at that pressure.
Okay.
Okay. Do you see that the further right you go into the so look at the slope of the curve between the vapor phase and the liquid phase.
Yes.
The line between vapor and liquid. Yeah, that one. See how that is sloping?
Yeah, it's quite a steep angle. Yes.
Yes. See how when you go to 100 bars,
Yes.
that in this diagram, at least
Off
at these temperatures, it
off the
will
page.
always stay liquid.
Yeah. Okay. I get that.
Okay.
But then the question becomes: can you prove what the pressure of the Earth is inside the Earth?
Yes.
How?
First of all, up to a certain depth, we can actually measure it directly. On the bottom of the ocean, it's over 1,000 bars. That's why it's so hard to reach it.
Yeah, but that's on the bottom of the ocean. No, we're talking inside the Earth,
Yeah, you can start drilling holes,
right? And we know the deepest hole in the Earth is they've ever did
15
was like
kilometers or something.
the Kola Bore mine in North Russia, and that was only
Yes,
8 miles.
yes. But the
So how
pressure
can we
at
prove the pressure?
that depth is already over 100 bars.
How do you know? Have you got any evidence for that?
Yeah, just do me a favor and look for Challenger Deep.
What was that word?
Challenger Deep.
I'm sorry, you'll have to spell that. Is it the word
Challenger. CHALLENGER.
Challenger?
Deep. DEEP.
Challenger Deep.
All right. Go to the wiki page. Just search for pressure.
Yeah, but we're not doing pressure of water. We're doing pressure inside the hole. You said inside the hole the pressure was already such. Whatever it was that you said.
Yes, but it's easier to demonstrate with water.
No, but I asked you specifically for the pressure inside the hole, and you gave me
look,
water. That's not what I asked for.
Then look for deepest boring hole or something.
Well, the deepest borehole is the Kola Bore mine. Shouldn't we be looking at that?
Yeah, maybe.
Right, so deepest drilled hole should be the Kola Bore mine. Kola super deep borehole consists of several holes. Right, this is where you'll find the pressure if it's in there. So in answer to the question, can you prove what the pressure is down there? Let's find if there's a Wikipedia page. Right, so I'm going to type search on the page for the word pressure. Is that okay?
Yeah, sure.
So where's the search button gone?
Control F.
Pressure. Nothing. So you've got no evidence for that assertion, then, have you?
Maybe if it isn't in this wiki article, it's somewhere else.
You can't claim it as a fact if you can't prove it. So there's
How's
nothing.
it called? The Kola borehole, right?
The Kola super deep borehole. You claim that the pressure was already above 100. So what's the evidence for that? Because I would think that the pressure.
Do you agree that if the deepest part of the Mariana Trench, which is
No,
Challenger Deep,
water.
yes, water is lighter. It has less density than rock. Do you know that?
Right, we're talking about the pressure inside the hole.
Yes.
I asked you for
yes.
evidence.
Yes.
You haven't
No.
produced
No. Yeah. Stop.
Right, the point we're trying to prove is what pressure is the iron inside the Earth. Because
Yes.
you were talking about this. Where was the one? This one. And your point was, where's it gone? As the pressure goes up, then the temperature goes up with it. Okay, I accept that. However, I'm asking you to prove.
Actually, no, that not the temperature goes up with it. The vapor temperature will go up with it.
Yeah, the point where it becomes from a liquid to a vapor, that goes up exponentially with the
You're
pressure.
correct. But you can see that already at 10, just look at 10 bars, right?
Yeah, but hang on. I accept it. I accept your point. That's not indisputable. What I'm asking is, what pressure is inside the Earth? And how do you know?
As said, with the deep boreholes, I just have to look it up. Give me a second.
Okay, take your time.
I'm not finding a value right now, but we could calculate it.
Well, we can demonstrate it.
You can demonstrate it, or what are you talking about?
Well, we can demonstrate the pressure of the Earth. Every volcanic eruption I've ever seen has been generally not that powerful. It runs slowly over
Not
the mountain.
that powerful. Yeah, but first of all, the volcanic eruptions don't directly come from the Earth's center. They are in the mantle. That's only a few kilometers under you.
Exactly. So, what pressure would you reasonably expect there to be under the in the what you call the center of the Earth?
You can
If a
calculate
volcano-
it.
Which is you can calculate it, but can you prove it? Because if you can't prove it, I mean, I would argue that the pressure here is
Yeah,
minuscule.
it's an extrapolation. For example,
Exactly.
we know. No, first,
basically-
yeah, stop. Let's start with something simple. All right.
Hang on. An extrapolation is not evidence; it's a calculation.
Calculations are evidence. We can
No, they're
use
not.
them.
They're a
Yes.
calculation.
For example, we know that when water, when you're 6 meters, 7 meters, I would have to calculate it. The further deeper you go in water, the higher the pressure, right?
Agreed, but I'm not asking about
And we
inside
can
the water.
calculate that. Only knowing the depth of the water, we can calculate the outside pressure. And that's the same with rock. The only thing we need to know is how much does the rock over you weigh, and how high is the column of rock that is over you to calculate the pressure.
Alex, here's a
Both is
visual.
equally valid.
Here's a good visual representation. You see my screen, yeah?
Yes.
Right. At the moment this erupts, the pressure is a lot higher than when it's settled down. Agreed?
The pressure is a lot higher.
As it's erupting.
No, the pressure on the magma chamber is or whatever is feeding the volcano is identical all the time. The only difference is that the plug, or however this blockade that is stopping the magma from coming, or the smoke from coming out, is no longer strong enough to hold it.
Exactly. So at the moment of eruption, the pressure is high. So what your graph is
No,
showing
no.
that-
The pressure is identical to before.
So all right. So in that case, then it doesn't make any difference about the strength of the eruption. What matters is that there's an eruption, and then we can basically conclude there is some pressure. But arguably, given that most eruptions are not that aggressive, most, not all, but most, the pressure is minuscule. It's not that much compared to like the Earth that we're on. But let's say that you are correct. Let's say that we'll go with your water. What's the pressure? What's the pressure in the ocean 2 miles deep compared to 2 miles inside a drilled hole?
The pressure inside a drilled hole, first of all, as said, it will be a little bit dependent on which rock is on top of it.
Well, there won't be any rock on
Let's
top
not
of
go.
it.
Let's not go with hole. We're in the middle of the rock, right? There's rock over us.
Yeah, but we're trying to prove the pressure inside the Earth. So to do
Yes,
that, how do we do that?
So you can't do it with atmosphere above you.
Exactly. So how else can you do it?
By applying a pressure plate.
Go on.
First of all, again, we can calculate how much, if we know how much weight or how much rock is above you, we can calculate the pressure. It's only the force that is applied by it.
Yeah, but I want you to show
divided by
evidence of what the pressure is, not a calculation of pressure. I want to show.
All right, again, let's go to water because it's much easier. In the
Okay.
challenge at deep at 10 or 11 kilometers depth, we have about 1,000 bars of pressure. The density of rock is about 3 or 4 times that of water. Therefore, we should have 3,000 or 4,000 bars. Continuing, if you extrapolate that, we end up with Earth core pressure, inner core temperature and pressure. Since you like using Wikipedia,
I don't. I hate using it.
then why do you use it all the time?
That's what you guys do.
No, I would actually, first of all, I probably start with, what the fuck are you typing there?
I'll see if you're watching.
Can you see my screen again?
Well, hang on. Are we still on the pressure of the Earth point?
Yes,
Can I see your screen? Let's have a look.
you should be able to. All right, so I just Googled for inner Earth core. What I would do now, first of all, I check, yeah, the values you were given were right, 5,700. Oh, was it Kelvin?
Celsius. I was using.
4,400 Celsius, 700 Kelvin, yeah. Pressure 330 gigapascal. If you have to calculate that or
Yeah, but Alex,
convert that to bars, that's no problem. You can do that. What I would do now is take a look at the
Hang on, whoa,
source.
stop. Before you do, let's just put this in context. Go back to that bit there. It says the temperature of the inner core can be estimated, and I'm asking for proof here, not estimations, but nonetheless can be estimated by considering both the theoretical and the experimentally demonstrated constraints on the melting. Alex, this is total conjecture.
No, it isn't.
It
Because no,
There's three words
No.
there that none of it are. It says estimated by theoretical and experimentally demonstrated constraints.
yes,
None of this-
experimentally demonstrated.
Yeah, none of these. This isn't empirical. This is pseudoscience.
No, it is empirical.
It's not. It's,
Take-
it's estimations.
No, taking experiments is literally not. It literally is
Yeah, but it's theoretical, Alex. It says
No.
theoretical, and it
and
says
experimental. As soon as you start doing experiments, it's empirical.
yeah, but it's pseudo. No. It's not empirical when it's based on theory. It's theoretical.
But
Alex.
it's based on evidence, on experiments.
Yeah, experiments that are theoretical. I'm asking for the
And
evidence.
no,
for the pressure.
no. Theoretical means that you start calculating it based on extrapolations, for example. And then
Alex,
you can check that with the experiment. That's why I'm trying to go to the source.
Alex, can I just check what this has got to do with magnetism?
So this is the source that Wikipedia is citing. All right. It's shown. I would need a geologist for this. Is Purple Dan here? So again, going back to the estimation. Even if you agree it's just an estimation, I agree it's just an estimation. But
agree
it's the
it's
best. But it's the best that we have.
There you go.
300.
So how? Let's go back to the content that you were talking about with the.
No. I want to continue this.
Why?
330.
What's the point? It's not
You
based on evidence or empirical stuff. It's based on pseudoscience. That's all it is.
It's the best we have. It's the best experiments we have.
It's not evidence though, and that's not acceptable. If that's the best
It
you've got,
is
that's not acceptable.
even if our knowledge is incomplete, we still have a pretty damn good clue about it, and we can make approximations about
Right,
it.
you
Even
don't know
if
the
it's not
pressure of the Earth.
completely, even if it's not completely accurate, we can use that value, and we can at least show how much those 330 gigapascals
can't
is
prove.
on that phase diagram.
You can't prove. That's the point. You can't demonstrate what the pressure is of the Earth to apply that phase dynamics or whatever it was. What was the thing that we were
Hold on.
showing before?
Let's calculate this in bar. 330 gigapascals. Ooh.
Right, Alex, we're at the point where I've asked you to prove the pressure so that we can apply the phase iron phase diagram, and we're unable to do it because you've not been able to prove the pressure other than theory. Theory's not proven.
As
Theory's stories.
Agreed. It's not proven, but it's the best approximation that we can do.
That's not acceptable.
It is acceptable.
Well, to you it might be. As a theoretical scientist, maybe, but to somebody
I'm
that's
not a theoretical
facts.
scientist. I'm actually a lab scientist. I'm cooking stuff.
Well, whatever. What I'm saying is theory is not acceptable as evidence because
It
isn't
is not a
evidence, it's
theory
just-
if it's experimentally at least hinted.
Father Christmas is a theory.
No, it's a hypothesis and it doesn't work.
Father Christmas is a hypothesis.
Yes.
Father Christmas is a theoretical being that doesn't exist.
Yes, and it's at least a hypothesis to explain something. But when you take a look at it, you can show that it's unlikely or impossible to be factual.
So, Alex, we're still at the point where you can't prove the pressure, therefore you can't prove the boiling temperature of iron. I'm not. You can't have conjecture. You can't have hypothetical. You either show it or you don't.
Let's do it the other way around.
Go on.
So can you please go back to the phase diagram? Oh, you still have it, right?
Yeah, I'm still on it. Yeah.
All right. So when you extrapolate this, let's just say that the temperature that this diagram continues to 5,500 degrees. Okay.
Yeah.
You would expect the slope of the curve between vapor and liquid to be at about at 5,000 degrees, maybe at about 50 or so bars. Let's just say 100 or let's just say 1,000 bars. Fuck it.
It's going to be about 3 bars, isn't it?
No, I think it's more, and you have to take a look at the scale that is logarithmic.
Yeah, but the point is, it's not a lot more than 1.
Yeah, whatever. Now compare that to the actual estimation on how high the pressure inside the Earth's core is at
Hang on, compare it to
3.3 million bars.
No, you can't do it to a hypothetical. It's either you know the value or you don't. If you're going to
If it's the best,
hypothesize,
if
then
it's the
it's
best
null.
estimation that we have, just
No,
compare
that's
how
not
huge
acceptable,
the
Alex.
difference is. I mean, if you're saying that at 3 bars,
Alex, how does this relate to the magnetism of the core?
it relates to you started with the fact that you said it's well over the boiling temperature, right? That was your what were starting with.
Yes, and that's what I said. So let me go back to it. I said the boiling point is 2,800. So what
Right.
you've got to try and do is get that pressure up to justify the claim that it isn't going to get to the boiling point. Or actually, no, because the Curie point is only 769 degrees. So that's the point where
But
it
the
loses.
Curie point is irrelevant.
No, it's very relevant because that's the point where it loses its magnetism. Agreed?
Do you know the Curie point of other metals?
How is it relevant?
That's just a question. Do you know Curie points of other metals?
Right, I can look them up very easily. Would you like me to look up a particular metal? Can we not stick to the iron because that's what the core is made of?
Yeah, all right. So the Curie temperature in Celsius is
Hang on. It's 769 Celsius, but let's go back to the point.
1043 Kelvin. Yeah, all right.
700 degrees Celsius. So according to this, iron will turn into a vapor at 10 to the power 12 or less of pressure. So it will be
in bars. That's literally a vacuum.
Yeah. So that's a negative value, right?
No, a value is never negative. This is still a positive value, only a relatively small one.
So basically, the pressure is going to be. So the only way that can do this, according to this, is in pretty much near a vacuum. Is that right?
Why would you want to have it in vapor, in the vapor phase?
Because once it goes beyond, well, all right, the Curie point. So the boiling point. Yeah, okay. Let's stick with the Curie point. The reality
go further to the right. If you have a bigger pressure, you're still under the Curie point, and you're at a solid.
Yeah, but
that's what we're at. We're below the Curie point, and we are in an environment that has enough pressure to have it as a solid.
What do you mean we're below the Curie point? We're not. We're way above it.
Look, no, currently here, we on the surface of the planet, take an iron nail, we're below the Curie point.
Yeah, but that's irrelevant. The point is the core is supposed to be 7,200 degrees C.
Yes.
So that's like 10 times the value that the Curie point is. So where's the, again? You have to prove the pressure, which we've already established that you can't do. So it's hypothetical. So the reality is, if the core's at the temperature that they say it is, the Curie temperature's been met, and look what it says. At temperatures below the Curie point, the magnetic moments are completely aligned with the magnetic domains of the ferromagnets.
Yeah, that's correct. That's how the Curie temperature is defined.
So what happens above it?
You can't magnetize it anymore, but you can still have.
That's not true.
Yes, you can still have magnetic fields, inducted magnetic fields.
Correct, but where do they come from in the Earth model?
We have demonstrated with models. You can still have non-ferromagnetic fluids that produce magnetic fields as soon as there's a force acting on them.
Right, let's start at the beginning because I want the people in chat to see this because I want you to. You're literally gonna Curie temperature. I want you to correct me with where I go wrong here, okay? Because I'm stupid. I'm a baller. I don't know what I'm talking about. The Curie temperature, right, is the temperature at which certain materials lose their permanent magnetic properties to be replaced by induced magnetism, right?
Correct.
Agreed. So when you click induced magnetism, it says, let me find it, net magnetization results from the response of a material, in this case the iron core, to an external magnetic field. So unless it gets an external magnetic field, it isn't going to be magnetized. So where's the magnetic field?
Net magnetism from the response of a material to an external magnetic field.
So can you tell me on your model?
Wait, stop. The sentence continued.
Together with
any unbalanced magnetic dipole moments that may be inherent in the material itself, for example, in ferromagnets.
Yeah. So could you tell me where either of them to apply in this example?
Yeah, you have movements inside the planet.
Agreed. But the movements are based on what? The convection currents, essentially, right?
Yeah, for example, and also the rotation of the planet.
Yeah, sure. Coriolis force. Yeah, I get it. But if you need a lot of power, a lot of energy to keep that core at 10. Oh, what was it? 10? Was it 7,000 degrees? It's going to create convection currents, yes, and that will add to it, yes. However, it's not going to be the cause of it. Something has to feed that. Otherwise, it's going to be a perpetual motion machine.
No. First of all, magnetic field. No. First of all, what is feeding this is the rotation of the planet directly.
No, are you joking? It moves so slow that nobody can tell it.
So what?
Can you prove that point to be true? I'm saying that's bullshit. Can you prove that the rotation?
We've done model experiments of this.
Prove it then.
Let me
Prove
just
that
Google
the
it.
rotation of the planet causes the core to be as hot as it is, because otherwise it's a perpetual motion system.
No. Where's
Yeah.
the energy loss?
Where's the energy loss going? No. What's putting the
Yes.
energy back in?
What?
Forget the energy loss. What's putting the energy back
Forget
in?
the energy loss. The energy loss is relevant because it makes it not a perpetual motion machine.
No. The energy loss is irrelevant because if whatever is lost, whatever that value is, it has to be replaced by something. And you're saying it's the rotation of the Earth. Miles Davis says it's the gravity and the pressure and the rotation of the Earth and the convection currents. He says that's what the cause is. I call bullshit because you can't prove it. You're saying it's the rotation of the Earth. That's part of what he said. He gave 4 reasons. You give him 1. Can you prove that it's the rotation of the Earth that fuels the core?
Yes, because there are model experiments to demonstrate this.
Evidence, please.
Do you know about the 3-meter experiment at the University of Maryland?
You can show me. Demonstrate it on screen.
All right, just give me a second. Want to find the original paper. Just give me a second. By the way, somebody in the chat just informed me the air pressure in that 8 miles deep hole is 6.375 bars. That is only air pressure.
6.37 bars. I mean, like, we would have to see the evidence of that and see does that jive with what that map says and stuff. We can come back to that.
All right. I'm currently finding the source. I just have to disable my ad blocker. So this is not, first of all, let me share my screen. This is not a scientific paper, obviously, but it's good enough to demonstrate it. If you want to look up the paper, I could find it for you. So what they've done in Maryland is they've taken a rotating, let me just disable the sound. This is a rotating sphere with about 2.5 to 3 meters diameter, right? Hello?
Yeah, go on. I'm listening.
All right. And it contains 2 inner spheres. In the middle, there's a solid metal core. And around it, there's a layer of molten sodium. So sodium is a non-ferromagnetic metal.
But hang on. Shouldn't you be using iron, not salt? Sodium.
You would have to melt the iron.
Yeah,
so that would be really fucking unpractical. Sodium melts at 97 or so degrees centigrade, so it's easy to do it.
Yeah, but does salt have a magnetic field?
Sodium.
Sodium, yeah.
No, it doesn't. No, it's diamagnetic. It doesn't do anything.
So how is that the same? That's not a comparable test.
Yes.
How?
Because the iron at that temperature, as you said, over the Curie temperature will also be diamagnetic.
Yeah, but salt. No,
sodium.
It won't be. No, it won't be. That's the point.
Do you know what diamagnetic means?
Right.
What does diamagnetism? What is ferromagnetism? What is pyromagnetism? What is ferromagnetism and what is antiferromagnetism?
Right, you stuttered a lot there. What was the question?
All right, there are different types of magnetism, right? The most commonly known is ferromagnetism. That's the kind of magnetic behavior that iron, cobalt, and nickel show. Right? Then there is paramagnetism. That's, for example, radicals behave paramagnetically. For example, oxygen molecules are paramagnetic. Same goes for transition metal complexes with unpaired electrons. Those are paramagnetic. This is another type of magnetism.
Right.
Then there's diamagnetism. That's also another type of magnetism.
Alex, can you show me anywhere where spinning molten iron creates magnetic fields?
Iron, no. Sodium, yes.
Right, that's the problem. So show me something with iron.
You're moving the goalpost. In the beginning, we were at molten metals.
What do you mean? How am I? Well, that's salt. Sodium's not even a metal.
Sodium? What the fuck? Sodium is a metal. Sodium chloride is a salt.
Comparing. We're supposed to be comparing iron.
Did you just say sodium is not a metal?
I meant in this context, we're supposed to be comparing iron.
What is sodium?
What is sodium?
What is sodium?
we're supposed to be talking about iron.
What is sodium?
Right. Sodium is technically an iron, a metal, but it's not iron. So I'm asking you to demonstrate your point with iron, not with sodium. So can you show it with
why should I, if the magnetic properties are identical? Sodium is conductive and sodium is non-ferromagnetic.
Because
That's more than enough.
the claimed point of the core of the Earth is not sodium. The claimed point of the core of the Earth is iron. So I
Yeah,
wanted to show how
good luck repeating that experiment with molten iron. I know
Exactly,
at least
that's the
two
point.
reasons. I know at least 2 reasons why that isn't a good idea.
because it doesn't generate its own magnetic field would be one of them.
No, because it would probably melt through your floor.
That's a bullshit reason. Show how fluid iron can create a magnetic field in the way
I
that
can't.
you're showing. There you go.
I
So
can't because this
therefore it
experiment
doesn't feed
is hard
itself.
to do.
Therefore, it doesn't feed itself.
No. As
Right.
soon as we can show
Alex?
that rotating as
Yes
soon
or
as we
no?
can show that when you have a rotating setup like this with an inner sphere and an outer layer of molten metal, molten conductive metal.
Yeah, but I'm asking specifically for iron.
Yeah, and I said that's hard to do and probably not feasible in an experiment.
Then you can't prove that it does what you think it does then. Same as the pressure.
Do you agree that this experiment proves that metals can do that?
We're talking about iron.
That's not my question. Do you agree that metals can behave in this way when they're liquid?
I don't know about every single metal.
Yeah, metals in general. That doesn't mean everyone. In this case, it proves that sodium shows this behavior.
Yeah, but we're talking about iron. Does iron show this behavior?
Again, it's hard to demonstrate it.
So the answer would be no.
No, the answer is we don't know in this experiment.
Right.
But we can show that it's reasonable to assume it because
No.
this
It's a fact.
sodium-
It's a fact. Does
sodium show this
No.
behavior.
Alex, find me a source where it says that iron, in its molten form, can create its own magnetic field. Find me something.
As I said, I can't do it right now because I don't think an experiment like this exists.
So you can't assert it to be comparable then because it's reasonable.
I can assert it to be comparable because when we know that one metal that has set magnetic properties does it, another metal that shows the same magnetic properties might or will do it as well.
So let me think. Give me a sec. Let me look at something here. I want to see the properties of sodium. Properties of sodium, because I know the properties of iron do not do what you say they do.
Let me just share your screen again because I think I'm still sharing mine. Yeah.
I'm presenting to everyone, am I? No, I'm not. Am I?
No, you have to screen share again manually.
All right, so what I'm going to check is the properties of sodium, because I don't know anything about sodium, and you've caught me off guard, so let me just see what happens when I search for properties of liquid sodium.
By the way, you are aware that you're trying to educate the chemist on chemistry, right?
I'm trying to find out whether sodium is comparable. Does it have anything that's different to iron? Because I know that iron in its molten state does not provide a magnetic field. So I'm looking to see if there's anything.
It's molten. Yeah. The Curie temperature is should be below the melting point. Yeah. All right.
Give me a sec. I want to know: does it create its own? Does it create its own charge in any way?
Yeah. Again, if you want to look at sodium, go for the University of Maryland 3-meter experiment. This experiment shows that when you have sodium in a rotating setup, it will generate a magnetic field.
But I want to know why it does it, because I know that iron does not do it.
How do you know?
Because I've read it. This is why I can argue it with comfort.
Have you done the experiment? You said, I said in this setup, sodium will do it. You said iron will not. How do you know? You claimed that know if it does or not, I would have to do the experiment. The same applies to you. To exclude that iron would behave this way, you would have to do the experiment.
Right, so when I've done the Curie temperature of sodium, which is the point where it loses its magnetism, there doesn't appear to be an answer. That indicates it doesn't lose its magnetism.
Yeah, because it has no magnetism whatsoever, because it's diamagnetic. Is it diamagnetic? But yeah, let's just say it's not magnetic at all. Yeah, it should sodium. As a metal, it
Hang on,
shouldn't be magnetic at all, I think.
Is sodium piezoelectric?
I have no idea. Possible.
Balanced.
Do I know what is piezoelectricity? Can you define it? Because I don't think you know what it actually is.
Inside the pyramids? Do you remember when we had the pyramids talk?
Yeah, and I think you didn't define it back then as well.
Right, piezoelectricity is the movement of water creating a charge. And I'm asking, is sodium
No.
is sodium piezoelectric? Is sodium how do you spell piezoelectric? P-I-E.
PieZZO electric.
Oh, that's the wrong word.
Piezoelectricity is when you apply pressure, when you deform a crystal, piezoelectric crystal,
Sodium potassium. Hang on.
it will create a voltage. That's how these electric lighters work.
Right,
No?
hang on. This is indicating that sodium is piezoelectric, right? The question.
I don't think it is.
Well, it indicates it is. Potassium, sodium, niobate, whatever that is. Lead.
Oh no. First
Hang
of
on.
all, that is probably that's a piezoelectric crystal. Only because it contains sodium ions doesn't mean that it's sodium.
Yeah, but hang on. I'm kind of learning this on the fly right now, so don't rush me. Let me look through it.
Yeah, you should really take a look at basic chemistry. I mean, this is like maybe first semester stuff. Maybe.
Right. So so if it's first semester stuff, then you can give me a straight yes or a straight no. Is sodium piezoelectric? Yes or no?
No.
Are you sure?
Yes.
So why is it indicating with these articles that it is?
Show me the articles.
Electrical properties of
I'm
piezoelectric.
betting you a paycheck that it's not sodium directly. It's a sodium compound, probably a semiconductor. No, not what I'm talking about. Not a semiconductor, a crystal. If it's a semiconductor or not, I can't tell right now. But it's definitely not pure sodium metal. You know these how are they called? 1, 2, 3 superconductors. The one that when you freeze them, they become perfectly diamagnetic.
I'm not listening at the minute. I'm reading. So I'm looking to see whether sodium itself is piezoelectric or not, because that's where. Do you remember in the pyramid talk when we had the pyramid talk and there was sodium in the bottom of the that vent?
Yeah, sodium ions, not sodium metal.
Yeah, but it was the sodium. It was in its powder form, though, right?
And in what? Yeah, but sodium as a metal doesn't exist in a powdered form.
But it was found in the pyramid.
Do you know what sodium does when you have it on air?
No.
So we usually use sodium in the lab when we want to create solvated electrons in an ammonia solution. And when you take the sodium out of the container, it's usually stored under hexane, which is a more or less inert chemical fluid. You can store it in there; it won't start to burn or anything.
I'm sure.
The sodium, when it has contact with oxygen, it will immediately, well, not burn. It will become hot and it will become white powder more or less instantly, because it's reacting with the oxygen in the atmosphere. Therefore, you can't have, at least over long term, over a minute or so, it's possible. You can't have metallic sodium on air. That's not the thing, right?
I'm just thinking. Just bear with me a sec. I think that there's something to do with sodium being piezoelectric, like
No,
inside the
as said,
pyramids.
sodium isn't.
Well, I think that's why you're showing that something. That when you were showing that video, then I think it's got something to do with piezoelectricity, and that's why it's carrying its own charge or creating its own charge. The question really is, like I said before, why aren't you doing it with iron? And I think the answer is because it doesn't create its own charge. It's not piezoelectric in its form. So what I'm saying is, unless you can show that molten iron is piezoelectric, it is not going to generate its own charge.
Molten metal magnet. Sodium. Will spinning a foundry ladle filled with molten iron create a magnetic field? Molten iron river discovered speeding beneath Russia and Canada. As said, I think in this case it's the best if you actually read up the stuff that you're talking about. You need to actually know what piezoelectricity is.
Well, I know what piezoelectricity is, but what I'm saying is
no, actually you don't.
You're comparing sodium to iron and claiming that an electric charge can be created with sodium, and I'm saying it doesn't happen with iron. So
yeah, again,
need
how
time.
do you know? What's the difference in magnetic behavior?
I need time. Well, you're the one that's making the assertion that that liquid iron will create its own charge. I'm saying that's not true because there's no evidence to support it.
Yeah, because there's a metal, a liquid metal with identical or similar magnetic properties that does this.
Yeah, but it's not iron though, is it? That's the
Yes,
problem.
so-
I don't know about sodium, and you've blindsided me. So I need time to look into the claim that sodium does this, and I want to know why. And I can't answer that immediately. However,
All right, so let's just
however,
continue talking about this maybe next week.
no, hang on, we're not finished yet.
All right.
Let's go back to at this point. I'm going to look into the sodium claim, but you're at the point where you need to generate the magnetic force that's required in the core because the Curie temperature has been passed, and it requires an external source.
Yes.
back to-
Do you agree that when the sodium creates a magnetic field only by the rotation that I showed in that video, right? The only thing they did was starting to rotate this entire setup, and a magnetic field was formed.
Yes, but that's right. That was sodium, but we're talking about iron. You may as well talk about chocolate and sweets.
And no, because first of all, chocolates and sweets are non-conductive and
I'm chalking
they're not
cheese.
rotating.
I'm talking about opposite. What I'm saying is you're making something similar when I don't think it is. I can't prove it at this point, but you're the one that's asserting that molten iron can create a magnetic charge, and I'm saying that's bullshit. So I'm asking you to produce that point. Can you prove that iron in its molten state when it moves is piezoelectric? Yes or no?
Right now, no.
Okay. So
As said, the experiment usually shown is using sodium
okay,
because
but
it's
that's
just
probably
simpler to
because iron
handle.
doesn't-
Although you don't want any sodium fires or anything, so you want to take a look at that.
yeah, hang on.
But what I'm actually curious about is whether this is possible with mercury.
Forget mercury. We don't have a mercury core. We have an iron core. So
yeah,
forget,
as I said, I'm just curious about it if it works with mercury.
all right, well, do you can do that in your own time. Let's in our time. Let's stay on topic. It requires a magnetic core with an external magnetic source. There needs to be a source. So what is the
No.
source? Yeah, there does. It does. Let me go back to it and show you.
Yeah, but I already showed that with sodium, the only source that is needed is the rotation.
Yes, but I'm asking it with iron
Yeah, and how do you know that needs to be a different source?
because it says that it's a molten iron core when you get out towards the outer side of the internal of the planet. It's iron.
Yeah,
So-
so
Right, hang on. Go back to the definition because we'll get into the closure point now. The Curie temperature, it says induced magnetism. We were at that point before. We opened up the induced, and then it said net magnetization results from the response of a material to an external magnetic field together with any unbalance. So forget about the second part. Let's just give you that.
no, I won't forget about the second part because
I'll
it
give
seems
you.
to be
Let's-
relevant.
Together with, yeah, it's irrelevant.
No, if the sentence is continuing and it's literally saying together with, then it's probably relevant.
No, hang on. It says together with, I'm prepared to give you. So the second part of the sentence, I'll give you. What I'm asking is, where's the external magnetic field? So it doesn't get created by centrifugal force because you haven't found an authority to prove it. So what is
To prove what? You think that the rotation isn't proven again?
right? Let me clear it up so that we're very clear. You said that it was the rotation of the Earth that created the charge for the iron, and then you cited sodium as the one to do it. And I asked you to do it with iron, and you couldn't do it. So
yes,
you couldn't
because
do
it's
it.
just hard to do it with a molten metal that is like a few
Well,
thousand degrees
We
hot.
can put a molten iron into a receptacle.
Yeah, but good luck doing that in an experiment.
Yeah, but there must be somebody that's done it somewhere because otherwise you can't assert that iron will create its own magnetic field. Because otherwise it will be piezoelectric, right? That's back to the pyramids.
No.
But
You still don't understand what piezoelectricity is.
Alex, it doesn't create its own magnetic field. Otherwise, you would have
Stop.
had the
We need to stop this once and for all.
no,
As
no,
soon-
hang on.
As soon as you're claiming that piezoelectricity, you actually have to understand what piezoelectricity is, and you don't. You
Hang
simply
on,
don't.
I didn't claim piezoelectric. You
Yes,
did.
you did. No,
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 I
I
didn't.
no,
You're
I
the one
never said piezoelectricity. You
You're
were
the
the one who
that
took it up.
No, you're the one that said that the rotation of the Earth causes its own magnetic field. And the only way to do that, you demonstrated with sodium, was to get it to spin. Yes, that would be piezoelectric, but it's
No,
to do with
it's not
sodium.
piezoelectric.
It is.
Metals are not piezoelectric.
Metals are not piezoelectric. You just demonstrated that sodium can be.
No. Because
Yes.
you don't know, because you don't understand what piezoelectricity is.
Alex, Stop gish galloping. Can you
Again, define piezoelectricity.
The movement of fluid creating a charge. It's nothing more simple
No.
and complicated than that.
Google piezoelectricity. Go for it.
Oh my God.
Come on.
Movement of fluid creating a charge. Piezoelectricity. It's the electric charge that accumulates in certain solid materials such as crystals, certain ceramics, and biological matter in response to applied mechanical stress.
All right. Thanks. Now, first of all, it says solids. You were talking about fluids. Therefore, fluids are not piezoelectric, first of all.
But you were the one that claimed that
Second
sodium.
of all, it was talking about ceramics.
Yeah, but you're the one that cited...
Ceramics are crystals, a sort of crystal.
Yeah, but respectfully, you're the one citing
metals.
Sodium instead of molten iron.
Yes,
and I'm asking you to demonstrate molten iron.
Is molten sodium a crystal?
Pardon? Is molten sodium a crystal?
Crystal?
I'm not sure. I don't know.
No, it's not. To answer your question, it's not.
But it's irrelevant in any event because we're talking about sodium.
No. It is irrelevant.
No, it's not, because we should be talking about iron.
You were talking about piezoelectricity. And you just read that piezoelectricity is only possible in certain solid crystals. Now, how does sodium fit into the definition of the solid crystal?
Right. How does sodium fit into the definition of what's inside the Earth? Because it clearly states it's molten iron.
No, please answer my question.
Right. This is all based on you presenting the sodium as the explanation for where the charge comes from. And I said I wanted to look into it. So it's a distraction, it's a tangent, and it's irrelevant.
No, it's not a distraction.
You were talking about molten iron. Let's stay on topic.
You asked me in the beginning, you asked me whether I can demonstrate that an effect where molten metal
iron
is...
I didn't say metal. I said iron.
All right, I'll give you that. You said iron.
Yeah,
Therefore, then I said it's hard to do with iron because molten iron is fucking hot. Therefore, we need something that melts at a lower temperature, and they use sodium because it's a conductive metal.
Right, but we're comparing apples for pears.
No. We're conducting one molten metal with another molten metal which have similar magnetic properties.
Yeah, but you've dropped it on me, and we're supposed to be talking about iron, and I don't know anything about sodium, and I'm going to go look into it. But at this point, it appears to be.
But then you claimed that piezoelectricity was the cause.
Based on ignorance. Hang on, no, hang on. This is based on ignorance and being dropped on me. We should be talking about molten iron.
Wait, so admitting that you're arguing from ignorance on the point of piezoelectricity.
Absolutely, but what I'm saying is it appears to be...
Can you please repeat that? I just didn't understand you. Is that a yes or no? Are you arguing from ignorance?
Yes.
All right, thanks.
But you're the one that brought it up.
No, I didn't. You were the one.
You brought up sodium, not me. I asked you to demonstrate how molten iron creates its own magnetic force.
And I said it's hard to do it with iron. It's easier to do it with sodium.
Support your claim. So you came up with this alternative of sodium. And I said I didn't know anything about sodium. I would need time to look into it. But it appears to be piezoelectric.
No, it doesn't. You just read the definition of piezoelectricity. It only applies to certain solids.
No.
Not to liquid metals.
Alex, I showed you the indicated results that were based on piezoelectricity, and you said it's a compound. Okay, but in any event, it's irrelevant because you should be talking about molten iron. So
it's not irrelevant if you're making a claim that is baseless.
I'm not making a claim. You
were making a claim about piezoelectricity.
Because there were results that indicated that it might be. Now it might not be.
No.
Alex,
stop. You can exclude piezoelectricity as a source by default when you're talking about fluid metals. Are you still here?
Yeah, I'm still here.
All right. When you're talking about fluid metals, you can rule out piezoelectricity as a source by default and, by the way, also by definition.
Alex, I asked you about molten iron. You brought up sodium. I said that's not what we're talking about, and I'd done research there just on the fly just to see what properties it might have. It indicated something to do with piezoelectricity.
No, it doesn't. Again,
it did though. It did. I demonstrated it. We did it live. It brought up stuff indicating it, right?
Yes, and afterwards, I made you read the definition for piezoelectricity, and it completely proved you wrong.
No, it didn't completely prove me wrong because you're playing my own ignorance against me, and that's bullshit.
No, please read again the definition of piezoelectricity.
Piezoelectricity is the electric charge that accumulates in certain solid materials, such as crystals, certain ceramics, and biological matter, such as bone, DNA, and various proteins. So
Right,
are you
right.
saying because it doesn't say liquids, that therefore liquids are not right?
It's talking about solid crystals.
Right, so let's do piezoelectricity in liquids. Because you
All
know
right.
that piezoelectricity in liquids works, because we had it in the thingy.
You mean in the pyramid hangout where I demonstrated that you have no idea about electrochemistry?
A simple method to evolve. There you go. A simple method to observe piezoelectricity of liquid crystals. So you can
Still a
have
crystal.
piezoelectricity in liquids. Yeah,
Still a crystal, but sodium isn't a crystal.
doesn't matter. You were the one that brought sodium up, and it's a tangent. So the whole point here is
No, it's
moot.
not a tangent. You asked me for evidence that rotating iron can cause this, and I came with the closest experiment.
Yeah, but you didn't produce evidence of iron. That's
Yes,
the point.
but again, but with a metal that is similar in properties in terms of magnetism,
Well, I don't know that, so that's
and
my...
which is easier to do in under laboratory circumstances, simply because you don't have to deal with
Alex.
red hot glowing liquid iron.
Alex, you didn't produce evidence to support the claim that molten iron, when it's in its liquid form, creates its own charge.
Yes,
That's what you're...
yes, but I demonstrated that molten metals in general can do that.
No, you
But that
didn't.
is more that you have done
Specifically
already.
iron, right? You haven't got any evidence to prove that it happens. You need that to be able to have a magnetic core.
Not yet. As said, if this experiment was already done with iron, I don't know about it.
Right, so you can't say it's a proof. It's a fact then.
No, but it's more than I've done, because as said, we've
No, you've
demonstrated
done
that
nothing, no.
at least rotating metals can do that.
No, the problem is, right, you've got no evidence to prove that molten iron can cause a magnetic charge. So therefore, the core cannot be magnetized by the molten metal unless you can prove that it can. So like I said, what's the source, please? You haven't got any evidence to prove that molten iron is the source. So until you get evidence to prove it, it's fiction.
No.
You've got no evidence to prove your point, Alex. So until you get evidence to prove it, it's literally like Father Christmas.
What the fuck you're talking about? As again, we can demonstrate that other molten metals in similar circumstances can demonstrate it. All right? Do you agree with that?
No, because I don't know
Why
that what
not?
you're saying is true. Because I
I've
need
shown you
time
the
to prove
experiment,
what
and I've
you're
shown you the
saying.
links to it. You can look it up if you want. And I'll send you the links to the original paper and maybe the work group of the guys who are working on it.
You do not have any evidence to prove molten iron can create a charge. So you've got all your cronies in chat now that are all on your side, and they're all frantically looking for evidence to prove molten iron can create a charge. And none of them have found it. You've had 15 minutes, not one has found it. So if you can't
You mean
prove
in the
that
chat or
molten
what?
iron- What?
In the chat?
You'll have people working in the background frantically looking for you right now because they've done it in chat before with the other point about the pressure in the hole. So there will be people looking for you, for you right now to prove that molten iron can create its own charge. And you know what? The fact that they haven't come up with it means that it's bullshit. So it can't create
Not
its own charge,
necessarily.
Alex, unless you can prove it can. So,
Yeah, again, with iron, it wasn't done yet. But
right.
with
So you've got no
with a
evidence.
no, not.
You have no evidence, Alex.
No, wait, stop. We're trying to get as close to the conditions that we believe
No,
in this.
we're trying to prove that your assertion on that your model is true. Not
No,
that it's similar,
but
it's
what
true.
the scientists are doing, is they try to get as close as possible to the conditions that we think are in the center of the planet.
Alex, I've thought
And
of
the first step is to have a rotating setup of molten metal.
I've thought of a really good comparison. What
Yeah.
you're trying to describe, if I'm talking about if the question was why is salt water tidal and fresh water not, your answer is, well, water's very similar.
Can you say that again? You were cutting out for a second.
Sorry. If I asked you why is salt water tidal and fresh water is not, what you're saying is, well, water's basically the same. So, you know, it is just, it's very similar. But the fact is, it's different. So fresh water and tidal, there is a difference. Tides are the issue. So what you're saying is, well, sodium's similar, so it's effectively the same. But we know that tidal water is different to fresh water for some reason.
And first of all, the reason why salt water is tidal is because it's there are bigger water masses that can react to the surface of the moon.
No, it's because it's piezoelectric, dude. That's
What are you talking about?
salt water is piezoelectric.
If you took out all the salt water out of the oceans and you replaced it with fresh water, it would still behave in the same way.
No, it won't because it's got no salt in it.
Yeah, it would.
No, it wouldn't, Alex. You don't
We
understand
have
what
a
salt
model that
water is with
predicts
piezoelectricity.
the movement of the tides perfectly based on the movement of the moon around our planet and the rotation of our planet. There is no factor in there whatsoever that
Alex.
that determines the height or the time of the tides depending on the salt content in the water.
Alex.
Show one.
Show what? Sorry, I wasn't listening to you because you were gish galloping. What was your question?
What I said again. We have my question regarding the salt water or the sodium.
I didn't hear what your question was. You said show one. Show one what?
All right. We have a pretty solid model on how the tides behave depending on the movement of the moon around our planet and depending on the movement of the planet itself and basically the shape of the continents because they also play a role in it. There's no factor or there's no factor in that model in there nowhere that connects the timing of the tides or the height of the tides.
Okay, let's check this.
Let's
check this. Do you agree that this is the current model?
Let me just end my sentence, please. There is no factor that connects the salt content in the water in any way, shape, or form with the tides.
Yeah, there is.
Show it.
I will do. Do we agree at this point that this is the current working model? The way the sun and the moon is dependent on its proximity to Earth, creates solar tides, lunar tides, and the general bulge. That's
yes.
Yeah. So when the orientation is different, the bulge is different relative to the proximity of both bodies. Yeah.
That was a little bit weirdly phrased, but let's just say the cause of the tides is gravitational influences by the sun and the moon. Yes.
So when the orientation of both bodies changes, then the tide changes with it.
You mean when the sun and the moon are on the same side of the planet?
Right. What I mean is, if you have in this above illustration, when the moon's in this location, it pulls.
I think you're not sharing your screen.
Oh, sorry. It would help if I shared the screen. Hang on. Now I need to find the Hangout. I didn't realize I wasn't sharing. Yeah, I am sharing, Anna. I'm presenting. Oh no, I'm not sharing. Sorry.
All right.
Is that working?
I can see your screen. It's flickering.
What the hell? Hang on. Is that working?
It appears to be so, yes.
Sorry, I didn't realize that you couldn't see what I was looking at there. Right, so this is the current working model. You see the sun at the top, and relative to the moon's position, it creates, on your model, it creates the tidal bulge, depending on where the sun and the moon line up.
Yes,
and
that's
when
correct.
The sun and moon line up like in that orientation, then we get differences between the solar tide, the lunar tide, and it manifests itself accordingly. That's on your model, right?
Correct.
So when I move this out the way, and then I do, I need this one.
By the way, I was just informed by the chat that apparently the Great Lakes in North America have tidal effects. So that's fresh water having tidal effects, contrary to your claim. Again, I would have to look it up, but
I would need to see evidence of that claim because there tends to be a lot of claims here with not a lot of evidence. So on that pattern, I could say that's probably bullshit. If there was evidence to prove it, then I would accept it. But at this point, I would say probably not because there's not been a lot of evidence otherwise. Right. What's it called? Amphibiotic points. I think that was it. Yes. I always have to put amphibian in to start it off. Right. Are you familiar with this? Do you know what this is?
No, I'm not familiar with it right now. Let me just check it up. How is it called? Amphidream. Oh, fuck's sake.
If you start typing amphibian, it normally fills it in for you. Amphidromic point.
Amphidromic point. Amphidromic point.
I want one that's going to show me it in a nice. That one I'll do.
View
image. Yes. Can you see?
All right.
Can Can you see my screen?
Yes.
Do you know what this is talking about? Do you know what this is?
Approximately, yeah.
This is talking about the amount of tide that everywhere in the earth has. Now, if you notice around the UK, we have a very, very high tide. We've come across this before when I've been doing my own observations.
Correct. 50
Obviously-
meters or so, wasn't it?
Yeah, it's really high. I think it's 9. Some people have cited it at 15. That's too much. It's about 10, just under 10. So in these upper areas in the map here, you've got a lot of high tide movements. And conversely, in the lower parts of the map, we have not that many. There's more high tide, like red colors, up at the top of the map than there is down at the bottom. How is this possible if the moon is supposed to do tides equally all over the planet, depending on the position of the sun, the moon, and the phases?
That's simple. First of all, do you agree that the water can't flow freely across the planet? It can't rotate around the planet because there are continents in the way?
No, I don't agree with that at all. The water can flow because it can flow right the way around the bottom here. It can go through the Gulf of Mexico.
Yeah, but not in the time frame of the 6 hours or so of a tidal phase.
That doesn't support the claim that the when I had that other image up before. Hang on, where is it? That one again. Bring that one back up. So what you're saying then is that we shouldn't get this because the land is in the way. But this is
First of all, you have to take into consideration first that the planet is also rotating every 24 hours.
Yeah, but you've just said that the land is in the way, therefore it shouldn't give us like symmetry. But earlier on, you accepted that was what the model was. But now I'm showing you the nodal points with the tides, and all these are the high tides, which are in the northern hemisphere, and all the low tides are on.
No. This is first of all 0 by 15. Can you please define what the scale at the bottom is from blue to red? 0 is no tidal difference whatsoever, and 15 or 150 is maximum tidal difference, right?
Correct.
So okay, all right. That means that where it's blue on the map, there's no tidal difference whatsoever.
Which is impossible given the nature of the model that you just agreed to, because it would all be moving all the time.
No.
Yes.
Let's just take a look at the Central Atlantic. Okay, let's start with the Central Atlantic Ocean.
The center, whereabouts? Say Brazil.
Let's say south of Greenland, where this point is.
Okay.
A little bit left.
That
one. That's the one I'm talking about. Okay.
Blue bit, yeah.
All right. Let's just say the moon is standing at the same longitude. So the moon is currently right overhead. Okay. I mean, not directly above you because
shouldn't it then be red?
Yes, but no. It shouldn't be. No. Not necessarily.
Absolutely. I would say it could only be that.
No. Do you see how on the left side of the Atlantic there's also a red part where there's more tidal difference?
Up here?
No. That's the Pacific.
On the left-hand side of the... Oh, you mean up in...
the eastern coast of the United States, for example. Yeah, that one, or further south, there's another point of high tides. No, not that one. That one. All right.
How can it go from being red, like red's up here at the top there, to being blue in the middle? Shouldn't that be a constant rather than a variable?
No, it shouldn't. And the reason is that the water can't flow over the continent.
There's no continent in the way. It's free to move. That can't be a variable. It has to be a constant on your model.
No.
Alex,
no. Let me just, I think, am I able to draw it? I might be able to draw it. Okay? I'm trying to draw it. I think I can do it just with paint. It's simple, but it will do, I think. All right. So, can you see my screen?
Yeah, I can, yeah.
I hope this is simple. Would be simple enough. All right, so here we have the ocean floor. So this is a simple model of the Atlantic Ocean, okay? Ocean floor in the middle, one coast here, and one coast there, okay? That's our model of the Atlantic Ocean. Ah, shit. Okay. Let's just say that the moon is at that position right there. Okay?
Sure.
All right. Ah, shit.
While you're doing that, I'm going to be looking up the Great Lakes and see if there's anything special about them. With
No.
regards-
You have to look at the drawing, so I can go through this with you step by step. Okay. So let's just say the moon is over there, overhead. That means that the water will be slightly pulled. I'm gonna do this in red. So red is this side when the moon is on this side. The moon will be there, right? That means the gravitation of the moon will pull the water here. So the high tide is here and here's low tide, okay? Do you see that?
Yeah, I do. I see that.
Okay. Few hours later. Oh, wait.
But you do realize, though,
Few
Alex,
hours
there's no
earlier.
land in the way.
No, in this case not, because we're only talking about the Atlantic Ocean.
Correct.
Okay, few hours earlier. Yeah, a few hours earlier. All right. That's what you expect.
Yeah, but that's not what oh, hang on. Yeah.
The total amount, you will have neither high nor low tide on this side, and you will not have, let me just make this a little more straight. High or low tide on this side. And then, I hate paint. When the moon is over here, high tide on this side, low tide on this side. Simple model, but it's enough to demonstrate it. The total volume of the water doesn't change, and the central point is all the time more or less at the same position.
Okay, so let me go back to my screen.
As I said, that's just a very, very easy simplification.
Okay, so hang on. I need the thingy that I had before. Where's that gone? Ah, there we go. Right. So if what you're saying is true, then it depends. What you're saying is depends entirely on what this bar means, this graph means. Because I don't know whether blue means it's a place of low tide or is it a place of low activity.
It's a place of low tidal difference.
I don't know. I'd have to look to see.
Because as you can see, those points, how are they called again? Fuck.
Not nodal points. Tidal nodal points.
Amphidromic.
Yeah, amphibious.
Amphidromic points are always at a position where there's no tidal change whatsoever. By the way, I found another diagram in the German Wikipedia. Yep. Looks like that's what I'm expecting. Blue is in this case no tidal change whatsoever, and red is high tidal change.
Well, you're suspecting that, but let's see what that actual thing does. Let me go back to another reference and see if we have a scale on it to see what it's measuring.
So I'm giving this hangout 10 more minutes, okay?
Okay, well in that case, let's go back to
2.5 hours. Let's
go back to the salinity of the Great Lakes, because somebody said that the Great Lakes were tidal. Do we know what do we know what the rate is for the Great Lakes of the
no idea. I think you can look it up.
Yeah. Do you know what it is?
2 centimeters probably.
It was 5 centimeters of tidalness. So that makes me think that there might be something in that water that makes it tidal by a little tiny amount. So it might.
So wait, stop. Are you saying that if you had a more saline water,
it would be more tidal? Yes.
Automatically, even if it's smaller.
If you have a greater concentration of salt in the water, yes.
Even if the body of water is much smaller.
Yes.
Like, all right. So why doesn't the Dead Sea have enormous tidal amounts?
Do you know whether it does or not?
You can look it up. It will say 0.
Let's try. Is the Dead Sea tidal? The long range of tides of the open ocean are slightly reduced in the South China. A landlocked sea is the Dead Sea, the hypersaline lake between Jordan, Israel, and the West Bank.
So just for clarification, this is the most saline lake on the planet. It's, I think, 30 mass percent salt.
Yeah, I'm just trying to find out.
It's about 3% salt.
Because it should be tidal if it's got a lot of salt. The Dead Sea has tides.
Yeah, a biblical connection to tidal nodes.
Well, why does it matter whether it's biblical or not? It's to right. Hang on.
Because I wouldn't trust anything that comes out of scripture. Just check any other source you want.
Did you say 5 minutes left?
15.
15 minutes left.
Yeah, I want to end this at 22:55 my time. Actually, Microblog just corrected me. Yeah, there are indeed lakes with higher salinities.
Well,
But
that would explain the small tide because it's supposed to be fresh water. But if there's a little bit of salt in it, then that would indicate that that would be tidal to a certain degree. And it's only 5 centimeters.
the Dead Sea is literally 30 mass percent tides. What am I talking about? 30 mass percent salt. It's the density of the water is so high that you can swim in it. You float in it. You don't have to swim actively.
Well, the question that's posed here is, does the Dead Sea have tides? And the first answer says, well, yeah, it's like any other ocean, lol. It's called the Dead Sea because blah, blah, blah. And then the next one says, the tide in the Dead Sea is almost non-existent. So we've got one that says it is, one that says it's not. I would need time.
Yeah, the first one obviously doesn't know how what the Dead Sea is.
Right, so this one then says, sure, the waters are affected with the moon, so you may notice waters rising up slowly on the beach. So maybe that is tidal. Salt Sea, one of the biblical destiny, forget that one. I believe whatever applies to a big lake applies to the Dead Sea. You need currents in order to get tides. Dead Sea is totally dead, but with a pinch of salt. Well, it's got a lot of salt. The tide of the Dead Sea is not noticeable most of the time. How big is the Dead Sea? Is it big?
It's I think it's about the size of Lake Constance in Germany.
It has tides. It's called the Dead Sea. So basically, it's at this point, I would say that it may or may not have tides because everyone seems to be saying both. So I don't know at this point. I would have to look at weight and come back to you and see whether it is tidal or not.
So the Dead Sea, let me just check the size of it. It's 67 kilometers long and 18 kilometers wide. So yeah, it's pretty in the order of magnitude and the same size as Lake Constance in Germany. I think that one is 40 kilometers long. But again, you claimed that if it had more salinity than the Great Lakes, then you would expect more tides.
Yeah. So I'm going to look at, like I said, I'm going to look into that and see is that true.
I'm 100% sure that you won't find any official.
Well, I'm 100% sure that you won't find anything to show that molten iron creates a magnetic charge. So if, again, in the point where, here we go.
By the way, do you think your own blood is tidal? That's a question that Microblog is asking in the chat.
Tidal. It will be affected by you. I don't know how much iron's in your blood. Is that because of the iron in your blood, or is he on about the salt in your blood?
There's a bunch of stuff in your blood. I don't know about the salinity of it.
I don't know. I'd have to look it up. I'd have to see what I can find.
Probably maybe more than see what. I have no idea. Ask the biologist. That'll do. That's why we have him.
This is right. I've just typed in paramagnetic fluid in YouTube to see what comes up. So what this is showing is that a magnet can influence liquids. Yes. And if there's salt in the liquid, it will create movement. And what my assertion is that what we are seeing with the tidal map, what's it called, the amphibian, the amphidromic point, is showing that the tidal points are nodal and they are not uniform across the Earth. They are nodal. They are local to where they are. And I don't see how it's possible. Let's go back to that one. That one. I don't see how it's possible that there could be. Oh shit! I didn't do what I thought it was going to do. I hate it when that happens. View image. That's what I needed. I don't see how it's possible that there could be such a high tide in and around the Caspian Sea and the British Isles and up here. This should be even across the whole lot because of the moon, the pull of the lunar cycle, or the pull of the moon.
No, not necessarily.
It should be
because no, because
all right.
The effects when you're funneling like waves into a smaller base, you automatically get higher waves. That's for example why tsunamis strike harbor cities when they are lying in a small base, because the water's funneled up there. I could imagine a similar effect being the case here. But again, in this case, you would have to ask oceanologist or something. I don't know.
Alex, in the example that I gave you, the thing with the right, that one, in that, I'm going to try and show this. Right, basically, what I'm saying is, if because of the path of the moon over the Earth, it's predominantly with the sun and it's over generally the equator. We should be seeing all the areas around here being red, and all the areas to the top and bottom being blue. Now the areas are blue towards the top and the bottom, but the red points are not on the equator. That's the path of the moon, right?
No, first of all, there's a 5-degree difference in the orbital path of the moon. Then there's also a 23 degrees difference between the ecliptic and
yeah, but what I'm saying is the only point that's got a high point here on the equator is this one. But if you look at all the high points that are they're not on the equator. So what you're asserting is that this is created by bottlenecking of the land. I'm saying that it's nodal, local to the area it's coming from. It's nothing to do with the moon whatsoever. It's totally to do with the tides, and it's literally this. Sorry, not to do with the tides. It's to do with the solidity of the water, and this is what you're seeing. That makes more logical sense than what you're talking about.
Not necessarily, because I'm sure at this point that this was modeled out using
real evidence.
No, fluid dynamics and gravity.
Well, there's the fluid dynamics one there.
No, that's different.
Well, it's showing that. Did you see the experiment that Nick did from Phuket Word, where he put an egg in the water and added salt to the water and changed the buoyancy of the egg?
I could imagine how it looked like, yeah, but I haven't seen it.
Well, what I'm saying is that the solidity of the water does make a difference to. Well, in that example, it was changing the density of the water in relation to the egg. But in this example, it's showing that, well, basically that salt does make a difference. But anyway, this doesn't make any difference with regard to the original claim. Let's go back to the original claim. The inner core is supposed to be 7,000 to 10,000 degrees, whatever value it is. It goes beyond
5,700 Kelvin.
Well, 7,200 Celsius, just a number, but it's over and above the Curie point. Now, you made the assertion that it was because of the pressure that was allowing it to go higher, but you're unable to prove it. I then showed that the iron, there's no evidence to support iron to create its own magnetic field. It requires an external source for the core to be magnetized. And I asked, where was that external source coming from? Because you've not got the evidence to show that it's coming from the rotation of the Earth caused by the movement of the fluid inside. So that's not the external source. So there has to be an external source, otherwise the core isn't magnetized.
Yeah, as said, the external source is the rotation directly.
So, yeah, but we just demonstrated that it wasn't. You haven't got the evidence to prove that's true.
Yeah, again, as said, when one metal does it under that circumstances, it's reasonable to assume that another one does it as well.
Yeah, but that's a reasonable assumption. It's not proof.
Yeah, thanks for saying that it's a reasonable assumption. That helps me a lot.
Yeah, but it's not proof. So where is the magnetic core? Where is the magnetic force that's charging the magnetic center of the Earth? If you can't prove that there's an external magnetic source, I'm sorry, Alex, it loses its magnetism and it hasn't been replaced.
Yeah, that's because you don't understand how magnetism works.
Yeah, and you don't understand how evidence works.
Oh, for fuck's sake. So it's 22:52. Can we end it on that one, or do you want to add something more?
I kicked your ass, motherfucker.
No, I think you didn't. And
I know you think I didn't, but you've got no evidence to prove your assertions to be true.
Yeah, we could ask everybody who was in here.
I'll tell you what, Alex, I'll give you a week to go and find evidence to prove that iron in its molten state can be magnetized. It can create its own magnetism, because you said it was the rotation of the Earth, and I'm going to give you a week to go and prove that that's true. Find me any paper in college, in class, in school, in work, through microblogganism, through Sean Hufford, through Red's Rhetoric, through all of your cronies that are rapidly looking for evidence to support that molten iron creates its own magnetic charge. You've got a week. If you don't do it in a week, you've got to concede the point.
Oh, wait, stop. Then you have to concede that evolution is a fact, because you never came back on anything that we discussed in the evolution hangout in the beginning last year.
I can't remember what I was supposed to come back to you on the
you were supposed to come back on human chromosome number 2, retroviral DNA, and a bunch of other stuff. You never did. I gave you 2 weeks back then, and I still haven't heard back anything.
Well, if you get me the citation of what I said I would do, I will do it. But in return, I want you to prove.
Look it up in the first hangout we had. It should have been in the last 10 minutes.
Well, at the end of the day, Alex, a cat has never become a dog. That's the reality.
Oh, for fuck's sake. Yeah, and that's something that would exclude evolution. That would disprove it if that happened.
Exactly. Well, no, it wouldn't, would it? Because that's what evolution is. A cat becomes a dog at some point.
Nope. Cats and
Oh,
dogs share a
whatever.
common ancestor.
Anyway,
Do you become your cousin, or did your cousin become you?
yeah, but your cousin is the same derivative of the human. I would have to become.
Yeah, correct. And
I would have to become a whole different species, like
no,
a dog.
no. Let's just go a few thousand generations further. Are the guys living at the same time as you going to become you? No, they are not, because you have a common ancestor that was basal to both of you. But I'm not going to go into evolution. If you want to discuss this again, I'm all in for it.
You were the one that was brought up evolution.
Yeah, I brought it up because you didn't keep a promise. You gave yourself a deadline of 2 weeks back then, and you didn't hold it. So now you're expecting me to do something in 1 week.
Alex, I'd long forgotten about it, to be honest with you. It's a long time ago.
Yeah, I was about to say you're right, Molten, differently. Whatever. So, any final words? I'll give you 1 minute.
Yeah, produce evidence that proves that molten iron can become magnetic under its own influence. Like you said, the rotation of the Earth is what causes it. Prove it.
All right. Was it? Do you want to stay when I open the Hangout, or do you want to go?
Do I fuck? I'm out of here. You could all bitch about me when I'm gone, but without evidence, guys, it's bullshit.
All
But
right.
Alex, it's been a pleasure. I enjoy bullshitting and chatting and arguing with you. You're always polite, friendly, and I to be honest, Alex, you treat me better than most flat earthers do, and so does most people in your chat. So
I probably have too much patience for you.
yeah,
Nope.
but you probably don't have enough evidence for me though either. But anyway, I was ending on a good note. I was being polite, so let's take it as a polite, friendly ending. So thank you for your time. And I'll leave you guys to bullshit me about how dishonest and lying I was and all that kind of shit. But at the end of the day, guys, unless you can show that molten iron creates its own magnetic charge, I win. It's that simple. Later.
All right. Please do me a favor and still take a look at the link I sent you.
In the side chat?
No, in Skype.
Do you want me to do that now, or do you want me to do it later?
No, when you're gone. It was the shilling video that I did for
that
you
one.
to
Yeah,
win
right,
Dumb Fuck of the Year.
I will do. I'll leave you a nice comment, I'm sure.
All right. So, see you then.
See you later. Bye-bye.
Oh, that one was hilarious. So, who wants to join? Micro, you will want to join, and Hellsaw, you probably as well. Miles? Let's invite all of you. Fuck it. Oh, Marcos is here. Hello, Marcos. Who do I have here? Hellsaw, hello.
I honestly don't get how you don't just fucking explode.
Probably I will at some point, but not yet.
I need to fix my mic.
Sure. I need to close some tabs. So.
I wonder when he's actually okay. I wonder if Anthony's ever going to accept the fact that saying "prove me wrong" is not how things work, and saying that this cannot work without actually doing any of the basic research needed to understand if something works a certain way doesn't fly. And I'm thinking specifically on stuff like the magnetism and well, obviously also evolution that you just touched on, because he did promise. I remember it. Yeah. Speaking, using words would be nice. I remember that hangout.
Yeah,
And
that
he
was my
specifically
first one.
Yeah.
I just got to say, oh my God.
Well,
I hope that Steve is watching this.
He was not, but I was leaving comments to him saying
For
that, you know,
fuck's sake, he promised to watch it, and if he then discovered that Anthony is actually worthy of being the dumb fuck of the year, he would change his opinion.
well,
He has his own hangout going, which is why he's not watching probably.
For fuck's sake.
Steve had to start up a clickbait hangout to get more clicks by doing another G-Man hangout. Somebody who says he's never going to deal with again, but there he is having to get his clicks. So he's got to do that instead of this. I'm a little pissed off at him for that.
A traitor.
Well, no, I'm pissed off because he said he would make sure to watch this one because he wants to see if he's worthwhile.
Oh, if he even watches give him any 10 minutes of this.
Yeah, just give.
10 minutes.
You still have to rename this to where Anthony has some problems. SUM. Yeah,
That was
Anthony.
the stupidest one
Anthony,
in this
look
case.
up
No,
words before
no.
you spew them out of your ass.
No,
Seriously.
the something was not the stupidest part. That was like, okay, that can be explained by just not knowing math lingo.
Well, it's not even
the
math
other-
lingo. Micro, that's like first grade math.
Second
How
grade,
the
I
hell
would say.
That's math lingo. Math lingo for him.
So this is probably something that happened before I started watching because I forgot about it and watched
Yeah.
Dunkirk instead, which I guess was a much
Doesn't-
better.
He does not know the definition of sum.
Oh,
He thinks
Sum
so-
of all
he-
words.
He thinks has to do with the tides, which means that by extension he has to think that when the moon is overhead of you,
Well-
you should have more blood in your head.
Let's just recap some of the stupid. He doesn't know what sum means. He doesn't know what
He doesn't understand that you can measure variables even if they exist in an equation where you would figure them out using other things.
He doesn't know
well-
what piezoelectricity is.
that's
No.
what I just got. Yeah, that.
He doesn't understand evolution. He thinks tides has something to do with salt content for some fucking reason.
Yeah, he
Oh,
thought
oh, yeah,
sodium
oh.
is a source.
So sodium is salt, by the way.
Oh yeah,
Oh,
that one's good as well. He doesn't
That one really
understand-
stinks.
he doesn't understand the fact that you can use the property of one metal to give a reasonable idea of how another metal would react under similar conditions.
Well, here it is really simple. Sodium is paramagnetic.
Yeah, it was.
It has no magnetic charge of its own. It's not affected by magnetism at all. But it can generate a magnetic field just by turning it into a liquid and rotating it, giving it a spin. So a completely non-magnetic metal turned into a liquid can create a magnetic field just by rotation.
I posted a link for it. If Gio wants to post it in live chat, that's fine. It's from
And please,
physics.org.
I'm going to beg Anthony to do one thing, and I'm probably going to get shut off of YouTube for this. But get a hold of some sodium and salt your damn water with it for a while. I swear to God, you would do humanity a service if you did that.
But the sodium is not that bad, to be honest. If he did it with potassium or rubidium, that would be worse.
I
But
want him
sodium-
to take a lump of pure sodium and eat it.
That'll just get really hot and possibly cause a stomach fire. There's
Oh
probably
no!
there's probably not enough hydrogen in your stomach acid to actually cause
Oh no! It will do a lot more than that. Because remember, that sodium is gonna enter his bloodstream.
No, this is true.
He's gonna have fun with the few brain cells he has left.
As if he could afford losing more of them.
Yeah.
Exactly.
Well, it might cause a fission reaction, have him split up and give him more.
Oh, that's the troll in the chat. Sleeping with your wife, warrior.
Yeah, I saw that. That's really great.
To be honest, the lie of Riley was better.
Yeah.
Yeah, the lie of Riley has been hanging around in a lot of comment sections for a while.
Yeah.
Gio, that was a nice call about him forgetting to do that evolution thing. That was a great call.
Oh, there was no
Thanks.
forgetting involved. He never bothered to look.
Yeah.
Yeah.
If you ever actually do an evolution thing with him, please let me join.
Sure, I'll just give you my hangout so you can do it with my avatar and everything. Hey,
I'd join
Gio,
as
why is
well.
your voice so different?
You'd have two
wouldn't be able to tell the
biologists on the
difference.
case.
He wouldn't be able to tell the difference. He was. Remember when he wasn't able to tell the difference between me and Halsoy?
Well, look, he just made a stupid comment. Iron is not sodium, nor was the sodium done at 7,000 degrees and not at the right pressure. Here's a clue for you, Anthony, that you really might want to look up. Find out what the Curie temperature for sodium is. You'll find out that it doesn't have one. You can raise it up as high as temperature you want, as long as you get the pressure to hold it in. It doesn't have a Curie point
Yeah,
because it is non-magnetic.
No, he's gonna interpret he's gonna interpret that as it being magnetic all the time.
Oh God.
The constant, yeah.
Also,
if I know him right.
it needs to be said, at least as far as I know, though I'm not an electrical engineer or physicist or chemist, but at least as far as I know, it doesn't matter if a substance is past its Curie point, it can still the movement of the ions can still cause a magnetic field.
Correct.
That's right.
Correct.
You need some external thing to happen.
As
and
soon
that
as you have
external
moving
thing is
charges,
rotation.
you'll get a magnetic field.
Yes.
Well, going back to his whole angular size versus size of an angle, it's
Don't
the
remind me.
same fucking thing.
One is the mathematical thing, and the other one is the mathematical. Is that mathematical thing applied in the real world? That's
If
literally
you're-
what it is.
If you're looking at a tennis ball 4 feet away from you and you measure its angular, the size of the angle is 1/2 of a degree, its angular diameter is 1/2 of a degree. That's all it is.
He was touting this on Nathan's channel, this morning or yesterday, but he was saying that, I don't know if he said it on yours, but he was saying that Africa, with the way that the moon is pulling the tides, Africa should be full of water, you know.
Oh, for fuck's sake.
Yeah,
Well,
there
that
should
would
be
kill-
there
kill
should be
a
no
lot of
water near
farmers.
Shut him down.
there should be no water near the poles. It should all be bulged around the equator, flooding everything.
Yeah.
The dude has no clue.
Yeah, he thinks it should be 22 feet. You know, he doesn't understand that displacement's at a very large body. It would be
So
like,
before I forget it, for the
Golden
chat,
fuel.
please vote Anthony Riley for the 4th annual Dumbfuck of the Year, because
Yeah.
as I have demonstrated, indicated,
Exact-
whatever.
Sleeping Warrior, Anthony Riley. Exactly. You have just made my fucking point about angular size. Thank you. Absolute idiot.
Did he really just say that?
Yes.
You know what? You know what? I have to share the live stream so that it's documented.
Yes.
yeah.
I'm screenshotting it just for keepsake.
So
When you're talking about angular size, that is all you're measuring is the size of the angle that you're seeing.
there we go.
Wait, you need to know the distance. Okay, so when you're calculating the distance to an object, if you know the size of the object and the angular size of the object, you thereby know the distance.
What he's saying is literally comparable to saying that if you have an equation to figure out how much overall food you have, that you need to know how many oranges and how many pears you have to know how many apples you have. That's literally what he's saying.
We keep giving him the answer. The angular size is just how large of the area of the field of view it's taking up in your vision. Period.
Also known as apparent size, if that's
It
easy.
has nothing to do with distance. It has nothing to do with the actual size of the object. It's how big the object appears in your field of view.
Which is why it's called apparent size, and not
And-
actual size.
And when you keep quoting the from a certain point of view, that point of view is the observer. Has nothing to do with how far away the object is.
but
It's
the
just
whole
how much of a view, how large it looks to that observer. Angular size. That's it.
How can someone that natively speaks English have such a hard time understanding English words?
that's because
FASE doesn't know the definition of sum. Yeah, native speaker of English, my ass. He learned it from a Cracker Jack box.
Let's just say
I
he's
wonder when he gave up doing maths at school, because he talks about mathematics in the same way that I used to talk about it when I was 8 years old.
yeah.
Yeah, that's
This
like
is why
basic
you failed
stuff
on the
that you-
Harvest. This is why he failed on the Harvest Moon whole thing, and why he had to keep changing his claim, because he's an idiot. He doesn't understand that when he says that the moon is going to appear 8 to 10 times larger, that would mean that the moon would appear 4 to 5 degrees in the sky instead of 1/2 of a degree.
God, it'd be huge. Jeez,
Yes.
it would be huge. It'd be like a
Yeah,
Dover.
Oh yeah. and, also, we would be dead.
Hey, just to keep it on the hangout topic, can you imagine the fucking tides that would cost?
Whee! That would be a
Oh,
ton of faith.
fuck.
You would have
But only if there was
tsunamis
enough
everywhere.
salt.
Oh,
Yeah, I
Yeah,
mean,
you're right,
there's
John,
enough
I'm
salt in this hangout already.
Anthony, hold on. He says, yes, it is huge. We've got video evidence documenting the fact that it's not, and we still haven't seen evidence from you saying that it is. Just
Also-
saying. We've got multiple people who
Are we
reported
still
this.
talking about the moon?
Yes, he's bringing that up as, yes, it is
That was,
huge.
that was a joke.
Does Riley realize that there's a supermoon every single month?
Yeah, it's just normally not on the full moon.
Yeah, I mean, does he realize that? Does he know it?
I don't
Probably
know.
not.
Probably not.
You
Wait,
just
someone
asked
saying
it.
there was a
Wait, wait.
solar eclipse every month? Who was saying there was a solar eclipse every month?
That
Anthony
was him.
Riley.
That
was
would
him.
be
Oh, he
Riley.
was? Oh my god!
Did you see,
He's changed that claim twice since he made that initial bet.
Oh my-
Sean? Did you see my Riley nomination video, my second one?
Yes, I did, and I love that to death.
Did you see what clip I was using when I said when I quoted him saying that solar eclipses happen every month?
Yeah, the whole fanning the money thing.
Yeah.
Did you have to sell one of your vans to get that money, Anthony? One of your taxi vans?
So
Have you read your reviews on your own page yet? Yeah. You need to find a new job, dude.
So
I wonder.
think
Just a
Riley
question.
has a weird definition of pleasure.
If Riley's still listening to chat, he said
Oh,
he's gonna
he's
leave.
left.
Yeah, I know. But if
Oh,
he's still
he's a
there, if he's
sadist.
still listening, has he ever, at one point, ever, as long as you've interacted with him, Gio, at any single given point, presented anything that positively and exclusively confirms his postulates?
No.
I don't
No.
think so. No, I can't
Never
think of.
does.
I don't know any single occurrence. No.
Because since he keeps asking for evidence for everyone else, has he ever on a single goddamn occasion done that himself?
He has tried to produce evidence, but every time he does it, he produces evidence that shows the Earth.
It either
At
shows
least
that the
he's trying.
Earth is actually round, or it shows that he's a complete idiot who has no idea what he's talking about, or both. Usually
Well, at least
both.
he's putting himself out there. He's putting himself out there, unlike other flat earthers.
Wait.
At least he tries.
Oh, hang on. Okay.
still there?
You know what? Hang on.
Hang on. Anthony,
Okay, Al.
Anthony, the Curie point does not eliminate the fact that the iron, fucking, what's the word I'm looking for here now?
Coal,
No,
iron,
no,
liquid, iron.
no. The goddamn it, molecules, not molecules.
Atoms?
Atoms.
Yes, they can still move and cause a magnetic field, even if the metal itself has lost its magnetism.
Oh God, Riley,
Stops
I
looking
hope
with
you are
problems.
Riley, I hope you are listening to this because I am an electrical engineer, and as soon as you started saying that molten iron cannot, I wanted to reach through the internet, strangle you, and bitch smack you at the same time. Because take a conductor, wrap it into a coil, take an iron rod, which is at a much lower energy point than molten iron, and move it in between said conductors. And what are you going to do? Induce an electromagnetic field. You are going to create a charge.
I think the problem is. Oh, sorry. I thought you were done. Sorry.
I need to take a breath so I don't.
Because I think the problem is I think the way he's reading the Curie point, which is essentially it just means right. It's something even blacksmiths use on certain metals. Like if it's no longer magnetic, you got the material to the right temperature and so on. Now I think he reads it as if a metal has reached this Curie point and is no longer magnetic, that it no longer can have any kind of magnetical effects.
Yeah, that is
That's exactly what he's thinking. He's thinking as soon as the temperature is reached, even if you have a current running through it, it won't produce a magnetic field anymore.
Yeah, because it becomes a superconductor at that point, if anything at all.
Yeah. That superconductor thing, what the
The
fuck? That
higher-
came out of nothing.
Wait, did he talk about? Fuck, I've missed so much good shit. Apparently.
Yeah, me too.
You have a strange definition
Yeah.
of good.
Well, good as in it's a challenge to Fab2.
I'm sorry, but
This
he
isn't a
lost-
challenge to Fab to.
Now, keep in mind, Anthony's had like almost zero credibility for a while now, but he lost any remaining credibility, and he's actually lost any credibility he could attain for the next 20 years just by not knowing the definition of sum.
Yes.
Just saying.
Now, out of curiosity, though, what did he talk about when it came to superconductors?
Well, sorry. He mentioned He mentioned the molten iron being superconductive. I said, well.
I think he's called it a superfluid. I think it was superfluid he was talking
Hey,
about.
no, yeah, you're right. It's not a
Supercritical.
superconductive. It was
Yeah.
superfluid.
Supercritical.
Super
Okay.
critical. Yeah, super critical. Super critical. Oh, I'm getting mixed up as well. So for those non-chemists and/or physicists who don't understand it,
Because it's super hot, it's a super fluid.
I
Yes,
think
and when you have a liquid in a closed vessel at a given temperature, there will be a liquid phase, and when you rise that temperature and the pressure over a certain point, you won't be able to differentiate anymore between the liquid and the gaseous phase over it. That is called the critical point of the fluid. You are not really you don't really have a fluid anymore, and you don't really have a gas anymore. You can't differentiate it.
it's sort of a like floaty fluid.
Yeah, it's
Well,
hard,
no,
it's hard
liquid,
to describe,
not-
but
sorry,
you actually have to
floaty
see
liquid.
that once. It's fucking cool.
Yeah,
Yeah.
we're mixing up liquid and fluid. I think.
Yeah, I realized that as soon as I said it.
Yeah. Liquid and gaseous.
He hears these words somewhere, and then latches onto them and thinks that he can exploit them for flat Earth somehow.
That's
And
exactly what he does.
Just crazy, you know. He
this
never actually finds out what they mean.
Actually, I think we should strap him into the chair of a lecture hall. Doesn't matter if chemistry, physics, or biology. Open his eyes, Clockwork Orange style, and then let him sit there for like 2 semesters.
But if we do that, we have to do biology because biology, there's a good chance that he's gonna see some gross shit, and that means he will be punished as well as learning.
Well,
Somebody
who's
just
going to give
pointed
him the eye drops? Who's going to give him
Somebody
the eye
just pointed out
drops?
something interesting that I've never really thought of. Anthony supposedly left the chat under Sleeping Warrior, and immediately Buddy Boy joins in.
What?
I think
Buddy Boy has not been in this chat at all until Anthony left under Sleeping Warrior.
I thought I saw him earlier, but I might be wrong.
Sleeping Warrior, Sleeping Warrior.
Let's
Yeah,
not
you're
be
right.
all conspiratorial up in here, though.
And he's using
does
the
say
word gish galloping,
galloping.
and he's using the word you're wrong.
Yeah, so
This might be Riley. Yeah.
I'm going to see when this account was created. Because I know it used to be, what was his old name?
The first one was Anthony Riley, then The Life of Riley, and now Sleeping Warrior.
Well, Buddy Boy used to go under On the Level. I know that.
He's
Oh,
got some videos with a P900 and whatever. I think I've seen this account before, actually.
Scroll down and see what happened, what's going on.
so by the way, my brother just Skyped me. He's watched the Hangout as well.
Really, you're
he's-
torturing your family now?
No, I didn't give him any information about this Hangout whatsoever. He came in voluntarily.
That
So he's an
doesn't
idiot.
make it better.
He said that I should have Riley check his salt dispenser in his kitchen for tides.
Buddy Boy was created on May 14th of this year. He's got
Some
four
P900
videos
videos.
with P900s, all 5 months ago.
5 months ago,
hmm
June.
Yeah, I think I've seen the one with the blue flashing star one before.
He's got his audio on, so let's see if he actually talks or not.
Top comment.
Please
Congratulations. You've discovered both out of focus imaging and chromatic aberration.
Do you remember when
You know,
Nambi claimed that chromatic aberration is caused by CGI?
Mhm.
What?
Yeah. He
I
didn't.
do. Sad.
So Nambi is one of Riley's friends, and he said that first of all he was working for the television industry, and said that he would be able to see CGI if he saw it, and third, that chromatic aberration in imagery is a clear indication that it's fake imagery.
So
sense of
if I
CGI.
right now take my Sigma 70 to just 300mm lens, which is a cheap lens that has cheap glass in it, which causes chromatic aberration. If I right now take a picture of the screen of this Hangout,
Hold on. The screen is computer generated image.
okay, if I take I would say take a picture of my dick, but that's I don't have enough macro to find it.
You need an electron microscope, and at that
Yes.
point, a chromatic aberration doesn't really matter.
Atomic force microscope.
So if I were to take a picture and it had chromatic aberration on it and it's a raw file format, that means now that it's CGI.
Yeah, you can literally use the camera to delete things from existence. If you take a
So
picture of
let's take a high definition photo of Riley.
With chromatic aberration.
yeah.
Oh, Hillel, you didn't. Oh,
I think-
that is a nasty quote.
I think
He
most
quoted
lenses
me
have.
saying he came voluntarily.
I think most lenses have some form of chromatic aberration,
Yeah, you
with the exception of
literally can't get rid of it. It's
Yeah,
it's
I think-
a consequence of physics.
some really expensive prime lenses probably has a minuscule to
Yeah, where you
damn
won't
near
notice it.
non-existent, but
Yeah. But yeah, no, it happens for the same reason that a prism spits light.
yeah.
No, this is actually the first hangout where I've ever had to actually turn off the sound and look at something else because I was so close to just punching something. I literally went and read what, well, not homework, but
Do you
read
think
some
Can I get you
papers.
guys to? Can I get you guys to be silent for about 30 seconds? I'm listening to this radio in the background on one of these wide awake videos.
Sure.
Yeah, sure.
They are British accents.
Nice.
Because on none of the 4 videos does Wide Awake actually talk, but he's leaving the audio on the camera turned on. But on one of his videos, the Orange Fire P900, he does have a radio playing in the background, and it's all British accents. Oh, just saying.
Multi TomTom is here. Hello.
Multi dum dum. But no. Also, on top of you having to turn off the audio and look away for a bit.
No, that was
Kinda
me.
Glad I was in.
That was my crew.
Oh, sorry, I was moving the headphones around. So, my
Yeah,
apologies.
the Danish guy,
Uh,
Norwegian guy doesn't make much of a difference, does it?
Fuck you.
Both Vikings at heart, so fuck them.
Okay, I like you slightly more now.
Yeah.
Yeah.
But no, so I'm kind of thankful I was in the middle of a class, so I had a reason to turn it down.
So do
But
you guys
holy
actually
fuck.
think that this hangout was Riley's worst one yet?
Oh,
No.
oh yeah. No,
No.
I'm going to disagree just
Well-
because he failed on basic definitions for very basic words.
I kind
I
of
still
agree
feel
with
very
you,
wrong.
but
I
to be
still
honest,
think
I
the
think
pyramid
the
is-
pyramid one was
Yeah,
worse.
pyramid is worse because that is failing at. He literally failed at a level where, like, it's not just basic words; it's basic thought processes.
Yeah.
Well, that kind
Wait,
of still
what-
applied on this one, from what I heard.
Tonight, he got the definition of some.
And can
Yeah, and Ken, that's
Um,
true.
Gio, you need to make like a best of, like just a whole like 2 hours of just. Like,
Just-
Oh, no,
have, like,
no, I
blooper
would not survive
reels
this.
and Sounds.
Dude, cutting that 2-minute and 30-second video 2 days ago, that was almost killing me, and it is way worse than because look, here's the thing. When I talk to Riley in a hangout like this, I have to talk to him for, let's say, 3 hours, right? When I cut a video that is only
Yeah.
2 minutes long, I have to look through maybe 10 to 15 hours of Riley footage without the possibility to interact with him. So
Yeah.
Not only-
yeah,
that-
there was, like,
it's
to
actually
be
much
fair-
worse for me than it is to watch this stuff.
Not
To be
only
fair-
that,
to interact with him.
To interact with him, yeah.
To be fair, Gio, you can save yourself a lot of trouble about that whole looking through 10 hours of footage because you can pick any random Riley footage and find some asinine claim that he makes.
Yeah, that's true.
Random video, random timestamp, he's making an ass of himself. Plain and simple.
There were some crackers in there today, though.
Yeah, that we were.
Yeah, yeah.
Sodium
So-
equals salt. Oh
Yes.
my god, I
Good.
died when he said that.
And he did it multiple times.
Well, I'm not going to do a third chill video for Riley for the dumb fuck of the year. I'm sick of it.
You already did.
Yeah.
Oh,
Yeah,
yeah,
this hangout
that,
was it.
the hangout doesn't count. I mean, a compilation like the last two.
Oh my god. If Steve actually watches this, I know he's going to change his vote. Oh my god.
If he doesn't, I would if Steve doesn't change his nomination, I vote that we put him on the
Next year's list, yes.
Yeah.
Yes, Steve, I'm making this official. If you do not vote for Riley after this hangout, you are my nominee for next year.
Same here.
And it's specifically because you thought that Anthony wasn't the dumb fuck of the year, which makes you the dumb fuck of the decade.
And holy shit, is Anthony proving him wrong?
I think it's almost to the point where I think he consciously wants to get the award.
No, Gio,
Oh.
would you like to share what his response was about getting in last place last year?
Yeah, I'm just first of all I have to find it.
I love that. It's so beautiful.
So for those who don't know, I have a giant database of Riley quotes from Skype because literally everything stupid that he says, I documented.
There's literally a section of Gio's hard drive that is just, if you
Yes.
open it up, it's mainly black, but the rest of it is sort of the normal like goldy silver color
There it is.
of a hard drive.
Oh, let's see.
For some reason there are patches of it that are weird, like they're almost rusted. That's the part that holds these things.
There it is.
Congratulations, you are dead last on the dumb fuck of the year list. You have no idea how happy that makes me! Exclamation point.
Oh god! And now he's winning by a landslide.
I think he was
it,
just
it
happy
just keeps.
to be on the list.
Oh, there's so much good stuff in that folder.
You don't want to
I
see
get
it.
these like whenever
Multi Tom Tom in the chat. You like Anthony Riley? Go to his dumb fuck of the year video and thumb it down.
And go to
Yeah.
my Anthony Riley video and thumb it up.
It's
Here's the thing for all you people who are supporting Anthony Riley. The more thumbs down votes he gets on his videos, the lower his vote total ends up being.
Yeah. So go to the voting video for
So
him.
go for it.
Have a heyday.
So currently, Anthony Riley has 307 points in the 2018 Dumb Fuck of the Year contest. Tommy Hall, second place, has 241. So he's leading. Anthony Riley is leading by 66,
Oh, so
which is not bad.
he's increased his lead then from the last time I checked.
So yeah, Gio, if you want to put the link into the chat, so Multi Tom Tom can go thumb down on his video.
You mean the nomination video?
Yeah,
No,
Yes.
the actual vote video for Anthony.
that's on me.
Yeah, let me just find it.
If I was in front of my laptop, I would post it again, except I'm staring at brake lights in front of me.
So for everybody in the
I'm
chat,
beginning
I'm
to-
gonna send a link to a video, and everybody up or downvote the fuck out of it, right? There we go.
No, but
No,
Multi
if you
Tommy Hall is. I don't think he's flat earther. At
He's
least
not better.
that's
No.
not what he's nominated for. But you and him would probably go get along great. You're equally idiots.
Well, I think the worst thing Tommy Hall has done, apart from in certain cases being an obvious troll and a self-proclaimed, actually admitted troll, is where I think the worst thing he's done is claiming that cancer is healthy for you,
Yep.
and like he means that sincerely.
Oh, also the flu. You can't die from the flu.
Oh yeah, that's a thing too. Apparently.
So in Steve McRae's side chat, somebody just gave me a really nice compliment. Guy called Sanders. Quote, your latest video influenced me so much to make a soccer account just to vote for Riley again.
Oh, I made what, 10 of them?
Why are ballers so easily triggered? I'm not easily triggered. It's just
There's
stupid.
no one in here who's triggered. I literally just made a joke.
No.
There's just a few people in here who might pull the trigger in the near future.
The funny thing is, it's same with the. Was it in your hangout, Gio, or was it Steve's, or was it Red's? The guy that kept saying, "Oh, don't be so triggered." That's like the new. It's like
It was
like the
one of
new-
Red's hangouts.
Ah,
Yeah,
okay,
I think as well as was red.
Yeah, it's like one of those new things to say when you think or when you're trying to make a non-point. It's like saying, "Why do you swear?" or "Stop swearing," or the whole like "You're just an idiot." So
Well, that's Red style.
I love that there was someone who commented underneath their panel hangout, their nomination hangout for Dumbfucker of the Year, that they like the idea of the competition, the award, but they wish it had a different names because swearing apparently means you have a lower vocabulary. So in other words, he's telling us to use less words to use, so we will get more words.
So if
That's
somebody,
literally what he
one
said.
of my hangouts should ever decide to be annoyed about me speaking or insulting too much, I will just continue speaking in German.
Well, I was going to remind people, there have actually been a couple studies.
Studies, yeah.
It has been proven. No, people who swear actually do have an increased vocabulary, not decreased, and they are of a generally higher intelligence level.
Yeah.
So if you have a problem with me, Red, Sean, anyone swearing, you can
Go fuck
rightly go
yourself.
fuck yourself.
Yes. You can go fuck yourself, you cunt.
I also find it funny, the whole like, oh no, a certain word has a magical connotation that means that now you're wrong.
It's gonna melt my brain parts.
Yeah.
What brain parts?
I mean, okay, I'm of the school of thought saying that words don't have what's the phrasing? I think it's
Intrinsic.
Intrinsic meaning.
Inherent
Intrinsic-
intention.
Yeah.
yeah, it's kind of the same. Like
Their
offense.
sound.
Yeah, it's kind of like the same like offense. Offense is taken, not given.
But fuck is the best word, because it's the only word
It's
that's
the most
referred to
verbal.
it's the only word that's referred to as the F word.
It's the only fucking word that can be fucking used in fucking every fucking sentence and still make fucking sense.
It
Fuck.
can be used as,
And
it can be used as almost every word in the sentence. Fuck the fucking
fuck
fuckers.
the fucking fuckers. Beep, beep.
I still think
Sean.
my favorite word in that sense is buffalo.
Buffalo, 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 buffalo. Buffalo.
Yeah, I can find
Yeah.
the entire thing. Fuck.
There's also police. The police. Something like that as well.
Here it is. It's buffalo, 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 buffalo.
Don't make me go all Smurf.
Oh no.
That's a grammatically correct sentence.
Yes.
Oh, go Smurf yourself.
So let's wrap this up. He didn't understand what the sum is. He didn't understand what piezoelectricity is. He doesn't understand what
He doesn't know what sodium is.
He doesn't know what sodium is.
He doesn't know what the word can means.
He apparently doesn't know what a salt is. He apparently doesn't know what a metal is.
He doesn't know what stress for damn it, I can't talk anymore.
Words.
He thinks slow
Words
flowing
fucking
lava
over.
means volcanic
I would-
eruptions aren't violent.
Yes.
I would seriously like to know how he's going to put stress on a liquid in order to get an electrical charge out of it.
Yeah, how can you get stress on the liquid?
What?
I mean, my brain is mostly liquid.
Wait.
I feel
What?
pretty stressed out.
You couldn't put stress on a liquid?
In order to get an electrical charge?
Yeah.
No.
You can't have piezoelectric liquids unless it's like a liquid crystal.
Yeah, there are liquid crystal systems where that's possible.
No.
I
But-
think I'm
Yeah,
glad
but that,
I'm
it's not a
hanging.
pure liquid at that point.
Yeah, because it at that point it's technically like fluctuating between a crystal state and liquid, sort of.
So it's a super crystal.
Oh no, don't do this to me, Sean. By the way, he didn't talk about electrolysis, so I count this as
Well,
That's a
I
possible-
actually think he was going there with his whole tides bullshit.
do you think?
It was.
I think it was.
Yeah.
That is where he was going to go with his tides.
Yes.
Oh, for fuck's sake.
I'm fairly certain that he is connecting electrolysis and piezoelectricity. Well, what he thinks is piezoelectricity.
Because higher salinity in water makes it more conductive.
Does he know?
Which technically is not wrong.
But that's where he was going to go take his whole tide thing. That's why he said that tides only
yeah.
affect salt water.
Well, actually, Gio, what you should have
You have
done.
magnetism in there as well.
Yeah, but no, Gio, what you should have done was find a map of the salinity of the oceans and show them that and see if it matched the points, the tidal nodes.
I got to point out hypocrisy. Multi-tom-tom. For you to say you're all judgmental idiots, you're being judgmental. Dumbass.
Pot meat kettle.
Looking in the mirror there, buddy. Looking in the mirror.
Generalizations are all shit.
Just saying. The hypocrisy in Flat Earth is just amazing.
I just got that, Gio. Holy shit. I think Anthony might have killed my brain. I love that he kept accusing you of gish galloping.
Does he know the definition of gish gallop?
Well, he lives by it, so he has to.
Doesn't know any definition whatsoever. I think he never got any
I'm fairly sure he has some kind of vague idea, and he literally just threw it in there because he didn't understand what you was actually saying, so he thought it was irrelevant.
See, here's my take on Lily. I think he's got this calendar at home that has a word of the day, and it's all scientific terms. But he doesn't bother to look at the definition that's listed under it. He just says, "Oh, that looks like an interesting word. I'm going to throw that in randomly in any conversation," because that's what he does.
I wonder if he's going to come back to you on this on the tidal levels and the Dead Sea.
He won't. Of course, he won't.
How's the Dead Sea oriented?
I will just say this:
north to south.
I will just say this.
I figured.
I will just say this: there's tidal charts for every body of water that has tides. The Dead Sea does not have a tidal chart. Just saying.
Also, I'm still curious. I tried to ask this in live chat, and I sent it on Skype. I wonder what the magnetic field, because since he claims it's magnetism that causes tides, right? I wonder, first of all, that magnetic field should be easily detectable, and that, second of all, I wonder how a magnetic field of such a strength to pull that amount of water, because water isn't really magnetic in the first place. It has some dielectric properties, right? But
yes,
but it's so small. You need an incredibly powerful magnet to affect it in any kind of sense, and it needs to be in really close proximity. So I'm wondering how a magnetic field that's capable of pushing those bodies of water can exist and not just fucking turn everything else to shreds.
Number in my head, it would be on par of the field strength of an EMP from a nuke.
That's constantly happening. EMP is just one big pulse. This would be something along those lines, but never stopping.
Exactly.
Do you know offhand how? Because I seem to have read that one of the strongest magnets we have is like 10 Tesla or something.
10 Tesla is more or less the strength of a usual NMR spectrometer there. Yeah. So no, 10 Tesla. It's probably around 16, 17 Tesla.
Holy shit.
And for those who don't know, an NMR machine is a chemist tool use. It's the same technology that MIR scanners are based on.
Yeah,
I think the letter you're looking for, Micro, is MRI.
Yeah, sorry, I can't speak.
Yeah, it's a magnetic,
my brain is
resonance. Yeah, we are making hydrogen atoms mainly rotate.
Pretty much.
Which is why you use the scanner to look mainly at soft tissue, because it has a lot of water in it.
That's why it's so much more accurate than an X-ray.
Yeah.
Which is why they found the bulge in my back.
And even those magnets have a hard time pushing any significant amount of water. So you can imagine the fucking strength of the magnetic
Jared.
field required.
Okay, Jared, do we need to find you a clock tower and a bell?
No, it's in my lower back and it's pushing on a nerve. It's not that kind of bulge.
I couldn't pass that up, Jared.
But here's the thing. If you put me on the right clock tower in the right location, with the right arsenal, people like Lily would not be around much longer.
Just listen for the knocks on his doors. There's going to be people visiting him right now.
Still, if I ever manage to like somehow acquire the address of one of these flat earthers, I'm not gonna dox them or anything. All I'm gonna do is make what looks like a piece of official paper from the Illuminati and send it to them.
We would like to welcome you into our club.
No, like a warning from them.
Oh God.
Probably
that would be
Like a
hilarious.
link to like a hidden YouTube video or something.
Yes.
Akin to the anonymous videos.
Yeah,
Yes.
either
Oh,
either
God.
Illuminati stuff or something Satanist, like I don't know, a goat heart or something.
That's why I wanted to sign it with blood. Maybe have a wax seal on it, something like that.
Hey, Gio, did you know you're evolving into a flat earther?
What? No.
According to
If
Dum Dum, you are.
If that should happen, shoot me in the fucking face.
No problem.
But use at least 2 or 3 bullets simultaneously, just to make sure that it's quick.
Well, fuck, you specified quick.
50 cal BMG from about 100 yards. That'll do the trick.
Nah. A full
come on, pink
Magnum from a
mist.
a full Magnum from a Warthog should do it, right?
Fuck it.
Nuke.
Shotgun, nostrils. 10.
Nuke it from fucking orbit.
I read some fun facts about the Warthog, and one of them were simply if you can hear the gunshots, it wasn't aiming at you.
Yep.
Ugh.
Yeah.
Isn't that a Brit?
Yeah, that's a brrrt, and yeah.
Yeah,
That
and
was
with the
just,
way the gun is positioned, it actually does slow down the airspeed of the craft very slightly, but it does create an additional resistance when they
Yeah,
fire.
I read somewhere that the force of the force backwards of the main gun is actually more than one of the 2 turbines.
It's also like the amount of CO2 produced, and whatever else trace gases from the gun firing actually also runs the risk of choking the engines. So the engine igniter turns on when you press the ignition or when you press the fire button.
Oh, that is fucking amazing.
And the Air Force, Congress wants to retire the thing. Beautiful, and the grunts love it.
Don't they want to replace it? Don't they want to replace it by the F-35?
Yeah, they want to replace it with a piece of shit that can't do the job.
Yeah.
Shocking.
There's no other plane that can do what the Warthog does.
Well, no.
I'm more confused why they named the plane after what's clearly a land animal.
No,
Because
that's just
it
a
is-
nickname. I think the official name is Thunderbolt 2.
Because
Yeah,
it is
the
butt
official-
ugly.
Yeah, it is butt ugly, but it is mean, nasty, and strong as fuck.
Yeah.
And it was the test pilots that gave it the name Warthog, just like the
It takes 50
Two,
cal hits like a champ.
is officially the Raptor.
Yeah, it has. If I remember
yeah,
correctly, it
Fairchild
has 2
Republic.
hydraulic systems, and if both of them fail, you still have wires that are running through the system, so you can
Yeah,
still land it
Thunderbolt
manually.
2.
What?
Thunderbolt 2. Yeah, you're right.
Yeah, Thunderbolt 2.
Okay, it is fucking ugly. Holy shit.
Yeah, but okay, now go on YouTube and search up videos of it firing and just
Yeah.
Videos of that sort are called Brit compilation.
yeah.
I have one here that's just called Attack Run.
Yeah, I've seen some helmet cam footage of it, like some of the soldiers upload from actual combat, and they were stationed next to a building, and they were taking fire from the building. The A-10 came in. You just saw the entire building just get fucking lit up, and then you heard "Brat!" and the plane just went by, and they were just like, they stopped firing. So I think
I
everyone
wonder-
inside just got fucking deleted.
I wonder what the pilot is feeling when he's pulling the trigger. Oh no, I know it's recoil.
Yeah, they actually lose a lot of speed when they fire that thing.
So this was probably the last hangout this year with Anthony.
Probably, and then you know.
Yeah, because next week I have the one with how was it called, Truth Seeker.
Yeah, that's gonna
Yeah.
be interesting.
Don't remind me. And
He's-
I've already
he's a fun
invited Multi
character.
TomTom for a second one. So that might happen before Christmas, and over Christmas I'm not at home. I'll be at my grandparents' house for at least a week.
I am.
Ooh.
I might be close to your neck of the woods for New Year's Eve, actually, Gio. Well,
Where?
okay. When I say close to, I mean like in the general vicinity.
He's gonna be on your hemisphere.
He is already at my hemisphere.
Yeah. No, I might be traveling to Berlin.
That's
Oh, well,
not
that's
in
still-
his general area at all.
Well, it's just 4 hours to drive
It's
from
in
here.
the
so-
same country.
Yeah, I mean it shares the same borders.
Yeah, just for your info, Micro. From here, from Nuremberg to Berlin, if you have a fast car and the traffic is free, you can reach Berlin in 4 hours.
Yeah, 4 hours for me is from one side of the country to the other.
I think it's less.
Yeah, it is.
It's like 3 hours or something, I think.
Wait,
Yeah,
wait a
to
second.
drive all the way from well, unless you count Bornholm, but no one counts Bornholm.
Average
Uh-oh.
Average Joe 11 in the chat. Is G-Man taking on another flat earther?
What?
Oh
Please,
God.
no.
Please say no.
Dumb
But, you
versus
know,
dumb.
But for border to border, from my house to Sean, your place, which is not even, it's not quite halfway, is a 16-hour drive.
Yeah,
Huh?
I live in a fucking tiny country. What do you want from me?
Oh no, they're talking about travel times within country, Sean, and I just pointed out from my house to yours, which is not even half. It's a little under half. Is 16 hours.
I could probably drive to the tip of the Jutlandic Peninsula and back in less time.
I mean,
And that's literally going across the country and then all the way up and then all the way back and then across again.
the general group of us, like all the European folk, we three, so Hellstorm, Microblog, maybe Mariah, we should meet up sometime.
So
In
that's gonna
Liverpool?
be the non-American hangout.
Not America.
Yeah.
We should meet up in Liverpool. Just saying.
Oh no. Somewhere in, I don't know, maybe northern Germany, Hamburg, maybe.
We should take all our locations and just find find the midpoint between
That's
them.
probably gonna be like somewhere in the fucking.
That's in the middle of the North Sea.
yeah,
Probably, yeah.
in Skagerrak.
No.
Well, in that case, just
no,
go to
no,
Denmark.
Well,
Fuck it, there's probably wind farm already out there, so.
not in Skagerrak.
Maybe not.
And okay, it's you.
Oh
Do you
my
know
God!
where Skagerrak
Tom
is?
said something accurate. Tom finally said something accurate. He's not intelligent. He admits it. Thank you.
Okay, just so it's clear, Skagerrak is the water between the tip of Denmark and Norway and the bottom of Norway.
So I've just pasted the link to this hangout into the live chat again. Multi TomTom, please don't join. I can't stand a second flat earther today. We can find another a time for another time, but not today anymore.
Well, that might be a problem because he's got kind of a hard on for me now since he's seen me on camera.
Yeah. Anyways, if you join, I'll kick you. Fuck it.
Why are you so rude?
Do it.
Because
Come
I've
here,
spent the
Tom.
last 2.5 hours, maybe, talking to one flat earther, and I can't stand talking to another one right after that.
But I mean, okay, I'll give him this. He's better than Riley, at least from memory.
Hmm.
He only goes where he's wanted. You must not get around very much, do you?
So, Tom, as said, you're invited to join the hangout, but just not today. I simply don't have the mental capacity today anymore. And I'm a little bit drunk, to be honest. I've drank like 4 beers.
That is required to talk to Anthony.
No.
So what you're saying is you're drinking without us?
What a dick.
Yes, I have to. Otherwise, I would be
He's
dead by
German.
now.
He drinks all the time.
I'm not German. I'm Bavarian.
That's the same thing.
No, that's first of
One
all.
is a subset of the other.
Oh, well,
like-
yeah.
That's like saying that I'm not Danish. I'm Jutlandic.
So the cultural difference and the difference in language between Munich and Vienna is smaller than the difference between Munich and Berlin.
Okay, Gio, I got a question for you since you're Bavarian. What exactly is that filling made out of?
Which filling? First of all, I'm from
For the
Franconia.
donut.
That's the northern half of Bavaria.
For the donuts, you know, the Bavarian creams.
Bavarian? What? I think that's just a US thing about something that the Americans think to be Bavarian, but actually isn't.
Sort of like French fries.
Well, that's a little more close since French fry was invented in Belgium, and it's
How
likely,
these things called?
likely that they got their name because they speak French in Belgium, and the US soldiers didn't actually know which country they were in.
Bavarian what?
They're called Bavarian creams, and they're donuts. It's kind of like a custard type filling with a chocolate icing over it.
That's
really good.
Like
Oh, it's a variant of an eclair.
Ah,
Oh.
it's a sort of in Germany. I think what you're talking about. No, it's not really the same thing. so it's a kind of donut with topping and chocolate.
It's got a topping of chocolate. It's got a cream filling. It's kind of like a custard base, but it's got some other stuff in it to give it some better flavor.
All right.
And they call it Bavarian cream.
It's not a thing, at least here.
See, it's just that dumb American thing about naming stuff after countries that it didn't come from.
Oh,
Probably.
we do the same thing. Like carbonated water is called Danish water in Danish for some reason, even though we didn't invent it at all. Like white bread is called French bread, and we also have, for some reason, have a dish that's called Swedish sausage dish.
It's a fucking conspiracy. Get over it.
And by the way, for the beer nerds in the chat, I'm drinking wheat beer right now. Gutmanns Hefeweizen.
Damn
Damn it,
no, they're
Gio.
not.
What?
He said
Damn
Danish
you,
women
Gio.
are edible. They're not.
They're what?
Well,
Edible.
technically, he said Danish women are eatable.
Well,
Yeah, I'm translating from idiot to Danish.
Retard.
Depends what he means by eatable.
Oh,
hey,
God,
Tom,
no.
Tom, spell phase.
But yeah, no. If the Swedish sausage dish, if you actually ask someone from Sweden about it, they have no idea what you're talking about. It's literally just us that named it for no fucking reason.
But okay, I'm gonna head out, guys.
All right.
What?
Have
what?
fun.
What's
See you,
on?
Sean.
Come on.
Fun.
Wait.
What?
Wait. Hang on. Give me a few more seconds.
Oh no,
What have you done now?
I don't know, but I'm scared.
Don't be scared.
How so? It's you. I'm gonna be scared.
I promise
I'll be
Nothing.
the
it's nothing dangerous. Okay. I think.
You said that the
Still
last
morbidly curious.
But fuck. Hang on. I need to change something. Need to do like so. And holy shit.
Nice,
Don't put the chaps on. Don't put the assless chaps on.
Oh no.
Wait.
No.
Wait, aren't chaps assless by definition?
So, apparently, Riley is in
I
another
was
Flat
wondering-
Earth hangout right now. Flat Earth Debate 56 by Nathan Oakley.
Right?
Hey,
Is he
It's
declaring
just-
victory?
it's just
Probably.
been a long time, Sean. So I had to do this because I found it again.
Oh, jeez.
And
By
I
the
need
way-
to do.
Hellsoy, remember when we had that bet
Which
When-
one?
The one when I said that I would be able to teach Riley anything.
You lost,
Yeah.
dude.
Yeah, I lost. So what disgusting Norwegian food do I have to eat?
Lutefisk.
No, I'll
That
be
is
nice.
Swedish.
I'll say Smalahove.
Oh.
Smaller what?
Smalahove.
That's because of the noise.
You know what? Just send me a link afterwards and I will eat it. Whatever
So-
it
That's,
is.
that's because of the noise you make when you throw it up.
Okay, so no, I promise. Okay, when you make it, it kind of looks disgusting. When you serve it, it looks like any other delicious, soft, textured meat.
So
But
that's a phrase that should not be slammed together. Soft textured. meat.
Smaller of it. Ah, it's the sheephead thing, right?
Yeah, it's the sheephead thing. So it looks disgusting, but it's actually really, really fucking tasty.
All right. I'll try to find a Norwegian restaurant somewhere and eat that.
I'm sorry, but if you're gonna have meat paste, yeah, no.
Remember, the stakes were high. You were supposed to eat Met Eagle, and I think that is much worse than the boiled sheephead that you.
Yeah.
Oh.
So, Sean, you probably don't know that Met Eagle is basically chopped pork, raw pork, served with onions and formed the shape of a hedgehog.
It's so stupid.
So you're
What?
not only trying to make me like die of like many bacterial diseases from like uncooked pork, but you're
Yeah,
having
it
me
has
eat
to be
something I'm
fresh,
allergic
obviously.
to.
Fresh, uncooked pork isn't that bad.
So, you want to know what it looks like?
Oh yeah, because the
No, no,
French are so clean.
There we go.
It's adorable.
Holy shit!
It's
Oh.
adorable.
Yes, that is a thing.
I think
What?
my words when I first saw it was "What the fuck even." I think they were.
Yeah, that's the usual
That's
reaction
the
to
thing.
this.
I can't think of like a truly disgusting Danish dish. I really can't. And there should be one because every country has one.
Actually, look at that. That's a little bit worse.
Yeah.
Hey, it's Riley food.
Oh,
It's not purple though.
Well,
It's not purple yet. Wait a few days and we'll talk.
Send that to Riley snail mail.
He still hasn't sent me any reaction to his nomination video. Or not his nomination video, his
well, if he's
the
in,
compilation I made of it.
if he's in the other hangout.
I don't know. Let's see. Yeah, he's in here.
He's probably shouting victory.
He's talking right now, apparently. At least he's sharing his screen.
Oh good lord.
What was the hangout?
It's called Flat Earth Debate number 56 on the channel of Nathan Oakley 1980.
Okay.
I'll version of it. Derp, derpity, derp, 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 derp,
Helso, you've seen that, right?
What?
The video I sent to you. Did you see that?
I think I've seen.
The second Riley compilation I made 3 days ago? 2 days ago?
Oh, right. Yeah. I don't want to watch it again.
No, wait. Is it an insult to me or to Riley?
Wait, okay.
Riley.
Wait, Fano, you are gonna have to explain that. Scandinavians play planes with
Nathan
Scrabble
just-
tiles and explosives on the rest of the world?
Nathan just shot down Anthony. Anthony's trying to play this video, and even Nathan's saying, "This is pointless." I agree with Mark. This is pointless.
Oh, Truth Seeker is in there as well. Nice.
Yep.
Huh.
If they get any more people in there, it's gonna be a collapse into some kind of stupid singularity.
A singularity of infinite stupid.
I mean, they're already pretty dense.
You know, and when Jesse was,
Oh, Michael, that
sharing
was
all
the
those,
joke of the day.
No, it wasn't.
no, I know Sean.
Anthony is the joke of today.
Yes, and he,
Yes, he is.
it's glorious when actually another flat earther tells him that he's wrong.
Oh,
Is he
Nathan,
if
still
anyone
on
even-
Glowbusters or did they throw him out again?
I'm not sure about the whole thing.
I don't think they're
If
exactly
anyone
friends.
needed,
I know that they've been trying to not
If it-
mention him at any time possible now. After my videos.
I was gonna say, if anyone needed a final piece of evidence on why they should vote for Anthony on Dumb Fuck of the Year, that's it right there. When even other flat earthers say, "No, you're wrong."
This hangout and everything around him should solidify it for anyone that even remotely thinks about putting a vote for anyone in this contest. Well, using the word context is wrong.
The message to vote Anthony for Dumb Fuck of the Year apparently already has spread towards the Flat Earth side chat. Because there's some dude calling people to vote for him.
Even the flat earth.
So I'm starting to wonder if Anthony is going to get the record for largest victory.
That's gonna be hard.
That's gonna be tough, you know.
Because True Empiricism last year they did get like more than 800 votes.
Hey, we can make that happen. So again, everybody, create as much stock accounts as you can if you have the time for it. And vote Anthony Riley
Doesn't
for Dumb
take
Fuck
long.
of the Year. So I actually don't have a stock account.
I haven't had one yet. I've been contemplating on putting one in, but I don't. It's too much effort for me.
I have a few, but I've already voted with them, so it would make a difference.
I voted with this, and I voted with the taking a look at account.
So Riley's now leading by 68.
Woohoo! He gained 2 more.
Come on.
Yep.
We can increase that 10.
He already has more
Come on, people.
votes than brain cells.
Well,
I
dude,
think
he passed that when he passed that when the
had
votes
at 2
started.
votes.
Yeah, exactly.
So I think I'm gonna leave the hangout here, the title of the hangout just the way it is. It's just too perfect.
Did you
But,
change it to Anthony
so-
has some problems?
No. Angular size is the measurement. Angular size is the sum. The
my
best
God.
way to insult this guy is just to quote him.
He insults himself.
Yes.
Yeah.
He insoils
That's
himself.
the-
But okay, I am
That's
really
it.
out of here,
You
guys.
don't-
I'll talk to
Yeah.
you later.
See ya.
All right.
See you,
See you,
Sean. By the way, where was Sly? He was supposed to show up.
I don't know.
Fucker.
Who knows? Maybe something better came up. Don't know what that could
What?
be, but
Wait, are you actually saying there's something better than a hangout with Anthony Riley?
that's what I'm saying. I don't know what it could be.
Completely forgot about that in our roundup of all his mistakes. He tried to use the Pythagorean theorem.
Oh yeah, yes.
What?
Well,
Oh, for fuck's sake.
apparently he has no idea about geometry.
Well, I'm not surprised, but
Multitomtom just said the Earth is a tesseract.
No,
Oh,
the
yeah,
Earth is
my-
shaped.
Yeah, and my dick is gold plated.
And for those who don't know, tesseract is basically a 4-dimensional cube.
Everyone knows that the Earth is a 4-dimensional party horse with a hat.
I thought we all agreed on it being a Pac-Man level.
Well, it can still be that and be a party horse with a hat. And
True.
if anyone wondering what a party horse is, that's the trick. No one knows.
So it's currently 2 minutes after midnight.
Woohoo! It's tomorrow.
No, it isn't per
You're
definition not.
speaking.
It is tomorrow.
You're speaking to me from the future. What is
Yeah.
this magic?
Apparently, yeah, because time zones don't work.
Apparently, Jared, don't forget the fact that Multitomtom refused to answer my question last time when I asked him whether he believed that I'm in the future from him. Because he apparently didn't understand how time zones work.
That's exactly why I said that.
Oh, also butterflies.
I didn't get that butterfly joke. I joined late to that hangout. What happened? But I didn't join late. I was AFK because there was smoke in my fucking building.
Yeah. No. He said that Randy said that butterflies, because butterflies can take off from the earth, they have to be stronger than gravity. But why, if butterflies can be in the air, why can't I be, even though I'm bigger and stronger, or something to that effect?
That's exactly the reason why, because you are bigger.
Yeah, square cube law.
Yeah,
and
basically.
not stronger relative to weight/mass.
Yeah.
To the chat, multi-tom-tom, no, I don't lie. I asked you various times last hangout if you actually believe that I live 1 hour in the future from you, and you didn't answer. Well, you did answer, but you didn't answer the question. You said something different. So, no, I didn't lie. By the way, thanks everybody for the new subscriptions. I went up from 279 to 288, so thank you everybody. You will probably regret it as you get to see a lot of stupid. And I'm not talking about myself, obviously.
Well, you will become functionally retarded by the end of this.
You think that talking to flat earthers and Riley and especially Riley will have its toll on me?
I think it's I'm fairly certain that whatever they have is a pathogen. It is.
Do you think it's contagious?
Yeah, it is.
Can you
Yes, but-
transmit diseases through the internet? Well, apart from computer viruses.
You can
What are you,
transmit
nature
stupid.
hacker? That's not a disease.
No, you can transmit stupid through the internet. The only thing you have going for you, though, Geo, is your propensity to insulate yourself with alcohol.
Yeah, the alcohol forms a protective shield around your brain.
Hopefully. Yeah, it does it by simply blocking all the synapses.
It slows you
To
down.
the Cypher K85 guy in the chat, yeah, Anthony Riley said repeatedly that he doesn't think crepuscular rays are parallel. I had a hangout with him about this particular topic. It's on my channel. You can look it up. It was originally on Riley's channel, but it was before he deleted his original account. So the only source where you can find it is on mine.
You can actually see them on the Himawari footages. You can see crepuscular rays.
Yep.
Just saying.
Damn, it's a shame Sean left, because we got some great footage back in August of crepuscular rays, but I can't remember if we ever nailed down what the object was that was actually casting the shadow.
Didn't you? I think you came. You had it. It was between two things or something like that.
Yeah, we got it between a storm system that was going through, I want to say, Missouri, or a mountain at the extreme outskirts of a range in the same direction.
Yeah.
It was one of those two things. We were held down the exact time to see if it was part of a supercell of that storm front or if it was the mountain itself. But either way, it was not any of the objects that we could see on or past the horizon from where we were.
So I think you're already looking forward to my hangout with
Truth Seeker.
Truth Seeker, thank you.
Yeah, because
I was thinking about Flat Truth for the name, but yeah.
his
We're fine looking forward to.
It's not. Yeah, looking forward is the wrong word. The word here should be it's a date that I will note and sort of have some sort of expectation for, more than if or any other date where there's not a hangout with him.
Yeah, I mean, looking forward to in the same sense as the colonoscopy. You know that you won't enjoy it, but
that depends on what you're into, really.
What?
No, I can tell you. It's no. No, I've had one. No. Granted, in my case, he literally had to use like the suction cups and cloths and shit on the front of the instrument
Too much
to-
information.
to
Stop
untwirl
it.
my intestines because they had it's called Tomsling. I'm not sure if you say the same thing in Danish. Where the intestines actually like they're twisted like in a corkscrew.
Caution.
So
Hmm.
that was
I know what you mean. I can't remember what the word is.
let's call it less than pleasant.
Gods of fun.
Ugh. My fucking lower torso hurts just thinking of it.
By the way, there's some static coming from someone. I don't know who it is.
Probably me.
Did you already order the new microphone?
No. Oh, it's not me. No. I put it on.
That must have been me.
I put it on my Christmas wish list.
All right. Yeah, Micro,
Yes.
the Blue Yetis are currently very cheap on Amazon. I
Yeah,
got
you
mine
said-
for $99. That's like wait, divided by 2.
Thank you, Tamsling. That's the word.
750 crowns, maybe.
No, it's 1,500 if anything.
Not Norwegian crowns, Danish ones.
Yeah, I know. Ours are worth more.
Yeah, because you have all your fucking.
Oil.
We have all those dead dinosaurs.
It's not dinosaurs. It's
Shush.
it's dead trees.
No,
And
it's not plant matter. It's fucking dinosaurs. Get with the program.
Yeah, but you know that won't last much longer. Like in 20 years, it's over, right?
No,
No.
Whatever.
it lasts a lot longer. The current reserves last
Yeah.
for about 50 to 60 years, and that's without.
And we kind of sold them more than we should have when the area was divided.
Yeah,
Possibly because of one. Our ministers at the time was drunk.
You guys should reactivate the Kalmar Union.
I know.
Yeah, actually, there was someone did the calculations on it. All 3 countries would benefit from it.
Nice. I remember 4 years ago, I actually was in Kalmar.
It's not that exciting of a place, really.
Yeah, it was alright, nice castle. Nothing around it, but I think that's the thing for the entirety of Sweden. So,
That depends on where in Sweden you are. It's a big fucking country.
Yeah.
That is correct. But to be honest, Copenhagen was more interesting.
Oh, by the way, Micro.
Hmm?
If you want, so this I'm gonna send you a link on Skype. If you want, this is what I'm currently using. If you want, that could be my Christmas present for you.
That is actually the mic I have right now.
Oh, okay.
that I have broken.
Oh, you've broken it. Okay.
The thing. Well, it's still functioning, but I have to wiggle around the cable. I have bent the connections inside the plug-in.
Ah, okay.
So no, I put a.
You were too rough with it.
No, it's the fact that I had it on my I plugged it in at the front of the computer and then had the wire going all the way back and then up on the table instead of plugging it in the back of the computer, which was not a lot smarter, so I didn't trip over it and shit like that.
By the way, Hellsoy, so I just recently purchased a nice video editing program, right? Magix Pro Plus 2018.
Yeah.
My i7 is so fucking slow for video rendering. I think next year I'm going for a new CPU.
Well, I think it's in Q1 you will get the Ryzen Plus coming out.
Yeah. I'm not sure if I'm supposed to go for the Ryzen because Intel announced that the 9th generation i7s will become octa-cores.
Yes, but I'm not sure if it's going to be a tick or if it's going to be a talk.
It will be Cannon Lake, so the next one.
Okay, yeah.
So
It
either
depends.
that one or maybe 12-core Threadripper, one of the two.
Oh, Threadripper, yeah.
Yeah, that's definitely a possibility. But you have to keep in mind that I'm also high frame rate gaming, so 144 FPS.
Yeah, and so that's the interesting thing. Like, obviously, we have to wait and see. But if they manage to do the changes they've talked about anyway on the Ryzen Plus, because it's in Q3 or Q4, I think.
No, that's wait. Are
Yeah.
you talking about Ryzen Plus, Ryzen Pro, or Ryzen 2?
No, not Ryzen 2, not Ryzen Pro, Ryzen Plus. So because Ryzen 2 is going to be
12
like
nanometer thing.
Ryzen 2 is going to be like the 10 or 12 nanometer one. Which
No, that's Ryzen Plus. I think Ryzen 2 is already planned for 7 nanometers.
Oh shit! Well, you're probably right. Which, well, anyway, Intel has for the longest time struggled getting their process down. The manufacturing
it appears like they're doing that on purpose because 40 nanometers is simply so cheap that they can continue doing it for a while.
No, they've tried, but they've failed every time they've tried. Like, you can actually look up the history. They've tried many times. That's part of the reason. Well, obviously, they hadn't had any real competition, so they haven't had any real incentive.
Yeah, but now AMD is doing a little pressuring.
Yeah, so now they might need to actually try, but they've tried before and failed multiple times, which is one of the reasons people are speculating that when Ryzen drops down to 10 or lower, they will most likely beat them in every single use case possible.
Yeah, probably.
And I might do so for a long time.
Performance is fucking impressive. I mean, 8 cores, 16 threads, and that for less than $300.
Yeah,
I'm talking about the 1700. Obviously, the 1700X and 1800X are a little more expensive.
Yeah, but even like the 1700 and 1700X are virtually identical when you overclock both of them anyway. So it's
correct. It's just a binning thing. If you get the 1700 overclocked to a 1700X speed, they are identical.
Yeah.
Only that the 1700 will obviously use a little more TDP.
Yeah. So it's interesting. It's going to be interesting to see in I think it's Q1 Ryzen Plus comes, and in Q3 or Q4 I think Ryzen 2 is planned. If memory serves.
Already in Ryzen 2 and Q3, I thought that 2018 is only Ryzen Plus, and then 2019 was for Ryzen 2, because Ryzen 3 is planned for 2020, and that's the last year.
Yeah, no. From what I've seen, obviously I might have seen some speculative charts. But from what I've seen, Ryzen 2 was supposed to come in 2018 as well.
Yeah, I will have to do some serious upgrading. By the way, Volta came out today. Do you see that?
I did not.
The new Pascal, Titan, the new Titan GPU is here. It's Volta HBM2 memory, and I think 21 teraflops. So that's like...
That's not bad at all.
30 to 40% more than the predecessor.
Yeah.
Yeah.
Titan. Hey, they've changed the name to something actually fucking sensible. It's called the Titan 5.
Yeah, I know.
Oh, we have Steve McCrane there.
Hey, Steve, you already missed all the fun.
Oh, yeah.
And by fun, I mean the part where I would almost stab myself if I had a weapon available.
Okay, Steve, it's not like we've been chatting for some time afterwards. The actual discussion with Riley was, well, 2...
Close to 3, I think.
Close to 3.
250 or so.
Yes. We're currently talking about computer hardware, so nothing to do with that.
Yeah, I am completely lost.
So, Helzo, I'm probably going to upgrade my GTX 970 to the successor 1170 or 2070, however it's called.
Yeah, I have it. I have the 1070 right now.
Nice. Yeah, I think the 3.5 plus 0.5 gigabytes of VRAM that the 970 has simply isn't enough anymore.
No, it's not.
No,
it's
not. Definitely worth an upgrade.
Yeah. So, and you're gonna notice actually quite a significant upgrade.
Yeah, and my CPU has to go as well. I mean, it's a 3770K, but not enough cores anymore.
It's gotten to the point where if you look at kind of reputable, or not kind of, but actually reputable sources like Tom's Hardware and I forget what the other one I was mentioning, but they've actually updated their lists of recommended CPUs now, where they no longer actively recommend 4-cores to people.
Yeah, that's true. It's just games are optimized for 4 cores, right?
Well, it's
But-
it's not necessarily like they're optimized for 4 cores. It's just that the workload doesn't the workload isn't parallel enough that having more made sense.
Yeah, I mean the
for
6
gaming.
cores that the new i7 has, how's it called? 8700K?
Yeah,
That might be currently at least the sweet spot for gaming. Maybe.
yeah.
But
It's
for-
even to the
for-
point where 4+4 is kind of not enough either in certain
Yes,
use cases
yes.
for gaming.
So I think that the sweet spot for gaming might be 612, but for anything else, I think 8 cores now is a must.
I think
Yeah.
I think Multi-Tum just made the same mistake as Anthony.
Someone
In
of
the chat.
someone of an angle. What?
Steve asked angle. He read the title, angle size of sum of what, and then Multi-Tum answered sum of an angle.
All right, time to open beer number 6.
So yeah, Steve. Apparently, Anthony Riley doesn't know the definition of sum.
So wait, let's just make this a little shorter. Steve, why don't you just join?
And we can explain all of the wonders of the universe to you. More specifically, the wonder that is how Anthony is still capable of functioning, how he hasn't forgotten to breathe at some point.
I still need to watch the first like 2 hours of this and probably
Oh,
get on
don't.
the mannerism.
Don't, you will damage your brain.
Well, too late for that.
I love the fact that we can hear a beer being opened in the
Yeah.
background.
The
Come
bottle
on,
cap
Steve,
is
get your ass in here. Arrow and joining? What?
I should
Maybe.
probably pop some rum for this as well.
Yeah, I'm getting an hour and joining as well.
Shit. Yeah, then. No idea why that is the case.
Does YouTube fuck up the? Yeah, I'm getting the same error as well.
Shit. Then I think it's time to end this, at least officially. Steve, check out the first 2.5 or so hangout hours with Anthony, because I will guarantee to you, you will change your vote to Anthony from Tommy Hall. That's a guarantee.
Add person link.
Add person link. Yeah, add person link. There it is. If it doesn't work now, then I don't know what's the case. Yeah, in this hangout.
Getting the same error.
All right. Apparently, it doesn't work. So, Steve, just check it out. We can Skype afterwards if you want, but you need to see this. All right. So, thank you everybody for looking at the agony that I was going through with Anthony.
More like joining in with the agony.
Yeah, whatever. So, and please check out the rest of my channel. Not Anthony Riley's channel, you will hurt yourself. And obviously look forward to my next hangout, which will be on next Wednesday.